upon a time, there were 3 little girls who went to the police academy. And they were each assigned very hazardous duties. But I took them away from all that, and now they work for me. My name is Charlie.
Good morning, Discovery. That music, if you can call it that, is from your training team. We're assuming there was a really good story here, and we expect to hear it when you get back. Also, your training team would like to say they had a tremendous amount of fun with you over the last couple of years.
Hey, thanks, Steve. We've had a lot of fun with them. They've been wonderful. They've trained us up very, very well. We've had a great time with them. And yes, there's a great story behind the Angels. And I'd like just to say hello and good morning to the Angels and Joaquin, their fearless leader.
That sounds good. And Discovery, your messages are on board. However, last time we've checked, the printer was offline. I was wondering if you guys could check that at some point.
Yeah, we'll work on it.
Thanks a bunch.
Discovery, this is Houston. Are you ready for the PAO event?
Houston Discovery, we're ready.
Governor Perry, this is Houston Mission Control. Please call Discovery for a voice check. Discovery ISS, this is Governor Perry. How do you read me?
Governor Perry, this is Mission Specialist Mike Fossum on board Discovery. Loud and clear, sir.
Howdy.
Howdy.
Well, listen, I just wanted to call and tell you how proud we are. You make the entire state of Texas mighty proud of you, and of course the Aggies are all up in great arms and celebration today to have the first Aggie in space. So you're making some history, Michael.
Well, thank you, sir. I heard I've been missing a lot of get-togethers back home.
Well, we'll make it up to you. As a matter of fact, pass on to Stephanie that the chairman of the University of Texas Board of Regents has made available some football tickets over in Memorial Stadium when the Aggies and the Longhorns play. So now I will tell you, he's guaranteeing a victory for the University of Texas, but my job is going to be to make him have to eat crow on that one. So, but anyway, pass on to Stephanie that that's available for and for yourself and your family. So the Friday after Thanksgiving, hopefully we'll have you both back and celebrate a great trip and a great experience, and have you down on the 50-yard line of that game.
Oh, that would be awesome. Yeah, I look forward to helping Stephanie eat a little crow, too.
And listen, I just found out a couple of days ago you graduated with Sam Hargis from down in McAllen, and he's a dear friend of mine and married to one of Wayne Shower's daughters from there, and I know he'll want to say congratulations to you and job well done. And if it's okay with you, I'm going to give your mom a call after I get off the line with you.
Well, that would be very kind of you, sir. Actually, she's not at home right now. She's in a hospital down in McAllen, but appreciate that.
Well, I knew that she was having a little bit of goings on. So, but anyway, I'm going to give her a buzz and just let her know that you're doing a well of the job for us, and we're proud of you.
Thank you very much, Governor. I'd also like to send greetings to Jerry Patterson. He was an old neighbor of mine and a good friend for a lot of years. If you could say hi to him.
Yeah. Well, I'll pass it. I'll pass it on to him, and he is a fine one, and although you know he couldn't get in the Air Force, he had to go in the Marine Corps, as we like to kid each other.
You bet, understand that. And Governor, thanks for your support to the Space Center in Houston and to our nation's space program. It's great having, America's space home in Houston.
Well, it is, and again, you all make us really proud of the job that you do, and we'll continue to be supporting the space program. And those of you who day in and day out are the pioneers of the modern day that are really making a great difference. So God bless you, and gig 'em.
Gig 'em, Governor. Thank you very much.
All right, so long. Discovery, this is Houston. This concludes the event. Thank you, Governor Perry. And Discovery, we are now resuming our operational air-to-ground communications.
Hallo und herzlich willkommen, meine Damen, meine Herren, bei Alltag, unserem Begleitprogramm zur Mission von Thomas Reiter auf der ISS. Es ist ja heute der 10. Tag der Mission STS-121 und der 8. Tag insgesamt der Mission 13, zu der Thomas Reiter natürlich als dritter Mann gehört. Der ESA-Astronaut Thomas Reiter wird heute das Vergnügen haben, mit einer Schulklasse hier aus dem Kontrollzentrum in Oberpfaffenhofen zu sprechen. Das ist die Klasse 7a des Christoph-Probst-Gymnasiums in Gilching. Die sind schon hier, um ihre Fragen loszuwerden an den Weltraum, an den Deutschen im Weltall, Thomas Reiter. Aber vorher hat mein Kollege Michael Krohns noch andere Gäste bei sich, andere Astronauten.
Ja, so ist es, und wir müssen hier das Mikrofon wechseln, damit es nachher keinen Tonsalat gibt, wenn wir hochschalten zu Thomas Reiter. Und bei mir sind zwei Astronauten. Reinhold Ewald, ESA-Astronaut, Sie waren auf der Mir-Raumstation, der russischen Raumstation, und Pedro Duque, Sie sind der erste spanische Astronaut gewesen, waren 2003 auf der ISS, auf der ISS, die wir jetzt sehen und von der wir berichten. Alle Astronauten berichten von sehr tiefgehenden, großartigen Gefühlen, wenn sie auf die Erde runterblicken. Wie war das bei Ihnen?
Ja, es ist bei allem sehr, sehr eindrückend, auf die Erde zu gucken. Das ist ein Gefühl, das also sehr hoch zu sein, aber doch, man guckt auf die Erde und denkt an die Leute, die da wohnen und was passiert mit dem. Von Weltall sieht man viele Sachen wie Verschmutzung und sowas, und dann hat man einen großen Blick, sagen wir.
Das so, die Verletzlichkeit der Erde wird einem erst bewusst, wenn man da drauf guckt.
Ja, genau. Wir studieren natürlich die Verletzlichkeit der Erde von Satelliten an. Und unsere Augen sind nicht gut genug, um alles sehr genau zu studieren. Aber wir sehen manche Sachen, dass wir vielleicht nicht sehen wollen.
Danke. Reinhold Ewald, Sie sind Astronaut, wie Herr Duque. Was machen Sie denn, wenn Sie nicht fliegen?
Ja, das Beste, was man natürlich machen kann, ist den Kollegen, die dann im Weltall arbeiten müssen, zu helfen. Und das tun wir hier unten aus dem Columbus-Kontrollzentrum in Oberpfaffenhofen in der Nähe von München. Für alle Fragen, die das ESA-Programm, also das Programm der Europäischen Raumfahrtagentur angehen, die Thomas dort oben ausführen soll, diese Experimente. Für alle diese Fragen haben wir hier Experten, oder wir sind verschaltet mit Zentren überall in Europa, wo die Entwickler des Experiments, die fachkundigen Leute sitzen und so schnell wie möglich eben diese Fragen versuchen zu beantworten. Das ist möglich über eine Sprechfunkverbindung, aber wir haben natürlich auch andere Verbindungen zu Thomas über E-Mail etc., sodass er also nicht aufgehalten wird in seinem Programm. Und das läuft hier alles im Columbus-Kontrollzentrum zusammen, und wir üben damit schon mal für das Columbus-Laboratorium, das ist der Namensgeber, also das Laboratorium, das aus Europa zur Raumstation gehen soll.
So, und damit wir keinen Tonsalat haben, von dem ich eben gesprochen habe, beginnen Sie. Wir müssen jetzt die Tonverbindung herstellen, deswegen das Mikrofon an Sie, Herr Ewald.
Wir erwarten jetzt einen Anruf aus dem Kontrollzentrum in Houston. Im Johnson Space Center sitzen ISS, this is Reinhold Ewald at the Columbus Control Center in Oberpfaffenhofen, Germany. How do you hear me? ISS? Good morning, Thomas. Dobre utra, Pavel. Good morning, Jeff. I am here in the Columbus Control Center together with a class of students from the Christoph Probst Gymnasium nearby, and it's a 7th grade, and they are very interested in space question and will pose the question. With me as well is Conny Cimoch and Michael Krohns from Phoenix TV in Germany, and for sure Pedro Duque. So I hand over to you to introduce you and say where you are in the moment.
Yes, I assume we do that in German, correct?
Yes, you can switch to German or Pavel in Russian or Jeff in English as you like.
Okay, herzliche Grüße von der Internationalen Raumstation. Wir fliegen hier gerade über den Südpazifik. Das heißt, wenn wir jetzt aus dem Fenster schauen, gibt es außer Wasser leider im Moment nicht viel zu sehen. Ansonsten kann man hier im Hintergrund das amerikanische Lab sehen, in dem wir uns gerade aufhalten. Zusammen mit mir ist unser Kommandant Pavel Vinogradov und der erste Bordingenieur Jeff Williams mit mir hier. Und ich werde dann einige der Fragen, die jetzt kommen, dann an die beiden natürlich weitergeben. Und wir sind jetzt bereit, die ersten Fragen zu beantworten. Bitte schön.
Hello, Thomas, Pavel and Jeff. Greetings, this is Pedro.
Ganz herzliche Grüße, hier ist Pedro. Ich bin hier im Control Center, im Kontrollzentrum, und ich werde Ihnen mit diesem Experiment hier behilflich sein. Ich möchte gleich meine erste Frage stellen und die an Pavel und Jeff richten, meine guten Freunde. Wie fühlen Sie sich denn jetzt, dass wir hier ein drittes Besatzungsmitglied mit bei Ihnen haben?
Доброе утро, Педро. Я рад тебя слышать и рад, что ты с нами на связи. Спасибо за эту возможность общаться с тобой. Мы очень рады, что ты с нами.
Ich bin außerordentlich, ich freue mich außerordentlich, Sie zu hören, Ihre Stimme zu hören. Und möchte auch ein paar Worte an Sie richten. Wir finden es außerordentlich gut, dass Thomas endlich hier oben angekommen ist, dass wir hier zusammenarbeiten können jetzt und dass er die ISS-Mission 13, dass er sich ihr angeschlossen hat. Hier gibt es natürlich, das ist natürlich ein ganz anderes Leben an Bord, wenn wir jetzt ein Besatzungsmitglied mehr haben, aber wir freuen uns sehr darüber.
So, Jeff is very happy that Jeff ist sehr froh, dass er ein drittes Mitglied der Crew an Bord hat, und auch Pavel hat Grüße an Pedro gegeben. Er hätte ihn auch gerne an Bord, aber Thomas ist natürlich jetzt die Hilfe, die die beiden brauchen.
So for the crew, the students have just been learning
Jetzt,
the
die
Newton's
Studenten
laws.
haben ja gerade Newtons Laws gelernt. Ich frage mich, ob Sie... Ach, Sie demonstrieren ja die Schwerelosigkeit schon hier. Vielleicht können Sie uns noch ein bisschen mehr demonstrieren, vor allen Dingen unsere Studenten hier und Studentinnen.
Okay, Pedro once again.
Pedro, nochmal, das ist hier unser Crew-Notizbuch, das hier in der Schwerelosigkeit schwebt. Sie sehen, wie es sich hier verhält in der Schwerelosigkeit. Wenn wir also etwas hier verlieren, wenn wir uns etwas aus der Hand gleitet, dann fällt es nicht zu Boden, sondern es verbleibt und bewegt sich weiter. Und je nachdem, wenn es beschleunigt ist, bewegt es sich durch den Raum und wir müssen das dann wochenlang suchen. Wenn wir darüber hinaus auch noch mechanische Verrichtungen hier tätigen, dann müssen wir immer aufpassen, dass wir uns nicht so stark mit den Armen oder mit den Beinen abstoßen. Sind sie so ganz einfache Dinge, wie beispielsweise das Arbeiten mit einem Schraubenzieher oder so etwas, setzt voraus, dass wir unseren Körper vorher in eine stabile Position begeben und uns sozusagen bewegungslos machen, weil wir in dieser schwierigen Atmosphäre der Schwerelosigkeit sonst gar nicht richtig arbeiten können.
Sehen wir im Vordergrund mein Crew-Notebook schweben. Ich nehme das gerade nochmal, wunderschön in der Schwerelosigkeit. Wir selbst können uns natürlich in alle Richtungen bewegen, Kopf nach unten, ohne Probleme. Das ist ein tolles Gefühl, aber es hat auch seine Nachteile, insbesondere dann, wenn wir mechanische Arbeiten machen und uns mit Händen und Beinen entsprechend fixieren müssen, um diese Arbeiten durchzuführen. Das kann teilweise ziemlich schwierig werden. Und für diese kleinen Teile, Werkzeuge, Schraubenzieher, was auch immer, wenn man so ein Teil verliert, wenn das langsam wegdriftet, dann so angenehm es auch ist in der Schwerelosigkeit, aber der große Nachteil ist, dass diese Teile nicht einfach zu Boden fallen und irgendein Geräusch von sich geben dann. Man weiß, aha, man hat was verloren, sondern das schwebt einfach ganz leise weg und dann muss man mitunter Stunden, Tage oder sogar Wochen danach suchen.
Vielen Dank, Thomas, für diese Demonstration der Morgengymnastik auf der ISS. Das hat die Klasse 7a hier sehr gefreut vom Christoph-Probst-Gymnasium aus Gilching. Und bei mir sind 5 Schüler und Schülerinnen. Und Sabrina Seib wird jetzt die erste Frage an dich richten, Thomas.
Herr Dr. Reiter, wie empfanden Sie den Start auf der Raumfähre und hatten Sie Angst?
Ja, also der Start ist natürlich einer der Höhepunkte von so einer Mission. Der Flug vom Abheben bis in Erdorbit dauert ja nicht besonders lange. Das sind nicht mal 9 Minuten, bis man im Erdorbit angekommen ist. Leider nur sehr kurz, aber diese knappe 9 Minuten sind wirklich bemerkenswert. Man wird mit ungefähr dem Dreifachen seines Gewichts in diese Sitze reingepresst. Solange diese Feststoffbooster an der linken und rechten Seite des Shuttles in Betrieb sind, schüttelt das ganz schön da drin. In dem Moment, wenn die abgesprengt werden, ungefähr nach 2 Minuten, ist das dann etwas ruhiger und dann gewinnt man weiter an Höhe. Nach wenigen Sekunden durchbricht man bereits die Schallmauer und fliegt dann mit immer zunehmender Geschwindigkeit bis in Erdorbit, wo man dann ungefähr mit einer Geschwindigkeit von 28.000 Stundenkilometer die Haupttriebwerke abschaltet und sich dann in der Schwerelosigkeit befindet. Grund für Angst gibt es eigentlich nicht. Natürlich ist es, wenn man es so mal betrachtet, riskant auf so viel Tonnen von flüssigem Wasserstoff und Sauerstoff zu sitzen, aber die vielen Menschen bei der NASA, die den Start vorbereitet haben, die in den letzten Jahren dafür gesorgt haben, dass das Shuttle so sicher wie möglich in den Weltraum fliegen kann und wieder zurück zur Erde gelangen kann, haben dafür gesorgt, dass einfach die Sicherheit dieses Fluggeräts nochmal um einiges verbessert wurde, sodass eigentlich überhaupt kein Grund besteht, da irgendwelche Angst zu haben. Und ich denke, das Gleiche gilt auch für meine Kolleginnen und Kollegen, die mit mir an Bord des Shuttles waren. Denen ging es genauso. Die haben mit großer Freude diese 9 Minuten erlebt und hatten auch eigentlich in dem Moment keine Gedanken an irgendwelche Unglücke oder sonst irgendwelche Dinge.
Vielen Dank, Thomas, für diese ausführliche Antwort. Die nächste Fragerin ist Lisa Nürnberger.
Hallo Herr Reiter, was machen Sie, wenn Sie Freizeit haben? Hallo Herr Reiter, was machen Sie, wenn Sie Freizeit haben?
Okay, ich gebe mal die Frage, ich habe richtig verstanden, es geht um die Freizeit. Ich gebe die Frage mal an den Pascha weiter und werde das dann übersetzen.
Мы свое личное время в основном посвящаем, конечно, наблюдениям Земли, потому что, наверное, это самое интересное, что может быть в полете, увидеть Землю со стороны. Это всегда очень интересно.
Ich sagte, dass wir den Großteil unserer Freizeit eigentlich damit benutzen, um den wunderschönen Ausblick auf die Erde zu genießen. Wir fliegen hier 90 Minuten einmal um die Erde. Wir können hier ganze Kontinente überschauen. Natürlich machen wir auch Foto- und Videoaufnahmen davon, aber das ist eigentlich das Schönste in der Freizeit, diesen Ausblick zu genießen.
Dann ist also die Gitarre noch nicht zum Einsatz gekommen.
Nee, bisher noch nicht. Dafür war noch keine Zeit und ich muss immer noch die eine Seite, die gerissen ist, aufziehen.
Und der nächste, der eine Frage hat, ist Marcel Münch.
Herr Dr. Reiter, warum sind Sie für 6 Monate zur ISS geflogen?
Herr Dr. Reiter, warum sind Sie für 6 Monate zur ISS geflogen?
Ja, die Arbeit hier oben ist natürlich hochinteressant. Man beteiligt sich an wissenschaftlicher Forschung, an der vordersten Front sozusagen. Es ist hochinteressant, eben in all diesen Bereichen zu arbeiten. Darüber hinaus haben wir alle zusammen hier Bordsysteme zu warten, dafür zu sorgen, dass die Station überhaupt funktioniert und dass wir hier eben diese wissenschaftlichen Arbeiten durchführen können. Das ist alles hochinteressant und ich denke, dass die Ergebnisse, die wir hier erlangen, den Menschen insgesamt zugutekommen und uns unter anderem auch dafür vorbereiten, weiterhin den Weltraum zu erkunden, in vielen Jahren vielleicht mal zum Mond zurückzukehren oder sogar zum Mars.
Christopher Gruber hat die nächste Frage.
Herr Dr. Reiter, was bedeutet es für Sie als deutscher Astronaut auf der ISS mitfliegen zu dürfen?
Was bedeutet es für Sie als deutscher Astronaut auf der ISS mitfliegen zu dürfen?
Ja, das ist natürlich eine große Ehre, stellvertretend für das europäische Astronautenkorps hier oben arbeiten zu dürfen. Es ist ja nun der erste Flug oder der erste Langzeitflug eines europäischen Astronauten an Bord der ISS und leitet somit eine Phase ein, in der dann auch in Zukunft immer wieder meine europäischen Kollegen hier oben sein dürfen. Außerdem dient das natürlich auch dazu, um uns auf das Andocken von dem Columbus-Modul, dem europäischen Modul, vorzubereiten, das Ende nächsten Jahres hier hochkommen soll. Und so kann jetzt beispielsweise das Kontrollzentrum in Oberpfaffenhofen, in dem ihr euch zurzeit befindet, bereits etwas sich mit den Abläufen, die erforderlich sind, um so eine Raumstation zu kontrollieren, vertraut machen und dann, wenn Columbus andockt, können wir direkt mit der Arbeit loslegen.
Vielen Dank. Die letzte in der Runde ist Franziska Pfister und die hat 2 Fragen.
Ja. Hallo Herr Dr. Reiter, gibt es auf der Raumstation Tag und Nacht? Gibt es auf der Raumstation Tag und Nacht?
Sorry, das habe ich jetzt nicht verstanden, ob es hier was gibt.
Tag und Nacht. Also ob man den Unterschied zwischen Tag und Nacht auf der ISS merken kann oder ob ihr sozusagen nur in einer Zeitspanne lebt.
Merken kann oder ob ihr sozusagen nur in einer Zeitspanne lebt.
Okay, Okay, so, jetzt habe ich es verstanden. Ich gebe das mal an den Jeff weiter.
Ja, das ist sehr schwierig hier, denn wir umrunden die Erde ja alle 90 Minuten und deshalb haben wir also Tag- und Nachtwechsel alle 45 Minuten. Man kann es also nicht so sehen wie Sie jetzt unten, dass wir eine ganze Nacht, einen ganzen Tag haben. Wir arbeiten ja hier nach der Zeit der Greenwich Time und wir haben unseren Tagesablauf, der ja von den Bodenzentren durchgeplant ist und uns vorgegeben ist. Insofern wird dort unten genau festgelegt, was wir zu tun haben. Wir gehen ungefähr 10 Uhr abends ins Bett nach Greenwich Zeit.
Ja, Jeff hat erklärt, dass wir in diesen 90 Minuten, die wir für einen Orbit brauchen, ungefähr alle 45 Minuten ungefähr einen Sonnenauf- und Sonnenuntergang haben. Das heißt, die Hälfte der Zeit sind wir in der Sonne, die Hälfte der Zeit im Erdschatten, also auf der Nacht. Unser Arbeitstag richtet sich nach der Greenwich Mean Time. Das heißt, wir stehen zurzeit morgens um kurz vor 6 auf, weil das Shuttle angedockt hat. Und der ganze Tagesablauf richtet sich genau nach dieser Greenwich Mean Time. Und in dieser Zeit stehen wir mit verschiedenen Kontrollzentren, mit Houston, mit Huntsville für die wissenschaftlichen Nutzlasten, mit Oberpfaffenhofen für die ESA-Nutzlasten und mit dem russischen Kontrollzentrum in Moskau in Verbindung.
Also auf der ISS ist jetzt 8:30, wir haben 10:30 und Franziska hat eine zweite Frage.
Ja, und zwar, wie lange und was man studieren muss, um Astronaut zu werden?
Wie lange und was man studieren muss, um Astronaut zu werden?
Ja, also um Astronaut zu werden, sollte man körperlich einigermaßen fit sein. Man muss keine olympiareifen Leistungen vollbringen können, aber man sollte schon gerne Sport machen. Man sollte in der Lage sein, gut im Team zu arbeiten, denn wie ihr sehen könnt, die Arbeit hier oben und natürlich auch die ganze Vorbereitung des Trainings ist richtige Teamarbeit. Man sollte ein bisschen Berufserfahrung haben, vorher ein wissenschaftliches Studium absolviert haben, Naturwissenschaften, Medizin, irgendwas in der Richtung. Viele von meinen Kolleginnen und Kollegen kommen aus der Militärfliegerei. Jeff ist beispielsweise Testpilot, ich bin Testpilot, Pavel ist Ingenieur und von unseren Shuttle-Besatzungen sind auch alle möglichen verschiedenen Richtungen vertreten. Das heißt, wir haben die Kolleginnen und Kollegen auch verschiedene Studien hinter sich gebracht, Physik, Biologie. Und wenn man dann ein bisschen nach dem Studium ein bisschen Berufserfahrung hat, dann hat man eigentlich alle Voraussetzungen, um Astronaut zu werden.
Vielen Dank, Thomas Reiter, für diese Antwort. Das interessiert natürlich auch unsere Leute hier, die wahrscheinlich den richtigen Studienweg schon aussuchen werden in 1-2 Jahren, um dann eventuell Nachwuchs zu werden für die ESA, um dort Astronauten oder Astronautin werden zu wollen.
So, danke Conny. Und wir schreiten zur Verabschiedung, Herr Ewald.
Ja, vielen Dank, Thomas. Spasiba большое, Pavel. Thank you very much, Jeff, für das schöne Interview. Wir lassen euch jetzt an die Arbeit und wünschen euch natürlich weiterhin eine erfolgreiche Mission. Счастлива полета. Have a good flight and we watch from Earth while you work and we want to support you. This concludes the event and I hand back to Houston ACR.
Wir wünschen euch viel Glück, wir beobachten euch weiter und wünschen euch viel Erfolg für eure Mission. Herzlichen Dank. Herzlichen Dank und viele Grüße nach Oberpfaffenhofen. Gut und auf Wiedersehen. Discovery ISS, dies ist Houston. Herzlichen Dank. Ganz herzlichen Dank. Danke an die Europäische Raumfahrtagentur. Wir beschließen hiermit dieses Interview.
Ja, und wir wollen noch einmal sprechen über das, was wir jetzt gehört haben aus der ISS. Sie selber waren in der ISS. Er hat gerade davon gesprochen, man muss teamfähig sein. Was macht man denn, wenn man mal einen schlechten Morgen hat, wenn man mal aufsteht und schlecht gelaunt ist?
Ja, das sollte man so gut wie möglich ausmeiden. Eines, das wir tun, ist, wir geben den Leuten so viel Arbeit, dass sie tun können, aber nicht mehr. Natürlich alle wollen, dass die Leute im Weltall jede Minute benutzen, um zu arbeiten, aber dann natürlich nächsten Tag muss man auch fit sein. Die Leute, die versuchen, am Ende des Tages ein bisschen Ruhe zu bekommen, ein paar Minuten auf die Erde zu gucken, um dann fit zu werden während der Nacht.
Wir haben eben ein schönes Experiment gesehen, Reinhold Ewald, Sie haben das auf der Mir natürlich auch selber erlebt in der Schwerelosigkeit. Das sieht alles so leicht aus. Ist das auch so leicht, in der Schwerelosigkeit zu arbeiten?
Also Thomas hat es ja beschrieben, es hat seine Tücken. Man verliert Dinge und man sucht tatsächlich danach. Wir hatten jeden Samstag Versteigerung, das heißt, wir haben dann von den Ventilatorschächten, wo die Dinge angesaugt wurden, die Uhren, die Bleistifte, die Kulis rausgeholt und gesagt, wem gehört das? Und dann gab es also eine richtige Versteigerung. Nein, ich denke, das ist eine Frage von ein paar Tagen, sich an diesen Arbeitsstil zu gewöhnen. An die Schwerelosigkeit kann man sich während des Andockens an die Raumstation ja schon in etwa gewöhnen. Die körperliche Umstellung ist dann abgeschlossen. Aber danach muss man natürlich auch mit den Tücken der Schwerelosigkeit zurechtkommen. Also Knochen und Muskeln regelmäßig trainieren, die ja durch diese Leichtigkeit des Seins, durch das Schweben überhaupt nicht mehr beansprucht werden. Und das tut Thomas, das tun seine Kollegen täglich 2 Stunden auf Laufband, auf Expandertraining etc.
Herr Ducke, sagen Sie uns noch etwas über die wissenschaftliche Bedeutung. Es wurde eben ja in der Schalte auch schon angesprochen. Vor allen Dingen auch, was macht hier sozusagen Oberpfaffenhofen dafür?
Ja, Oberpfaffenhofen koordiniert alle Aktivitäten, die von der Europäischen Raumfahrtagentur an die Crew, nicht nur an Thomas, also an die anderen, gegeben werden. Also wir haben so einen Teil der Zeit, einen Teil seiner Zeit und wir geben sie Aktivitäten. Das kann natürlich, wenn Columbus da oben ist, dann werden wir andere Sachen auch haben, aber jetzt haben wir nur wissenschaftliche Aktivitäten. Wir haben Wissenschaftler auf alle Länder in Europa gesucht, die besten, und die brauchen die Schwerelosigkeit, um seine Experimente fortzusetzen oder zu beenden, damit die Experimente völlig zu Ende kommen. Und diese Experimente sind das, was Thomas tut. Es gibt nicht sehr viel Zeit, also die Experimente sind sehr, sehr ausgesucht.
Herr Ewald, am Montag wird das Shuttle wieder landen und dann beginnt oben für Thomas Reiter so die richtige Arbeit. Der muss da, glaube ich, erstmal aufräumen, nachdem die Kollegen weg sind.
Ja, unterschätzen Sie das nicht. Er hat also schon an die 10 Tonnen Material zusammen mit seinen Kollegen aus einem Behälter, kann ich mal sagen, einem Gepäckbehälter, das nennt sich MPLM, also ein angedocktes Modul, in dem diese Sachen verstaut waren, in die Raumstation transportiert. Er hat etwa 3 oder 4 Tonnen Material aus der Raumstation, gebrauchte Sachen, die man unten auf der Erde nochmal genauer unter die Lupe nehmen will, wieder in dieses Gefährt getan, das jetzt morgen dann im Shuttle wieder untergebracht wird und zur Erde zurückkehrt. Also das war schon kräftige Arbeit. Wir haben ihn kaum sprechen können, so beschäftigt war er. Das geht natürlich auf 6 Monate nicht in diesem Zug weiter. Wir müssen jetzt eine Regelmäßigkeit einführen. Die Crew hat auch samstags und sonntags frei, wo also keine Arbeiten geplant werden. Man kann das einfach nicht in diesem Tempo 6 Monate durchhalten. Und die Gefahr ist natürlich dann, dass es langweilig wird. Aber da hat der Pedro ja schon gesagt, wir versuchen möglichst dann auch in der Woche, wenn Arbeitszeiten sind, sehr interessante Dinge mit ihm zu besprechen, mit ihm zu planen. Und er hat ja auch noch seinen Ausstieg ins All vor sich. Das ist also sicherlich einer der nächsten Höhepunkte, wo auch viel Vorbereitung reingeht und wo er sich darauf konzentrieren muss.
Herr Ducke, nächste Woche geht es mit dem wissenschaftlichen Programm los. Was ist da am Anfang das Wichtigste oder womit beginnt man?
Wissenschaftliches Programm hat schon begonnen. Heute haben wir 2, 3, vielleicht 3 Experimente, wenn es Zeit gibt. Das Wichtigste am Anfang ist das Wechsel des Körpers und einfach zu studieren, wie die menschliche Körper sich aufpasst zu Schwerelösigkeit und auch mental. Und das ist das Wichtigste am ersten Moment, weil dann natürlich, wenn das später getan wird, dann ist es schon passiert.
Ich darf mich bei Ihnen sehr bedanken für die Kommentierung. Ach so, ja.
Eins habe ich noch. Ich habe mich sehr über die Frage gefreut, wie wird man denn Astronaut? Denn das zeigt die richtige Einstellung. Wir haben ja gesehen, das sind vielfältige Aufgaben, das ist eine richtige Herausforderung. Und wer sich dieser Herausforderung stellt und wenn es dann auch noch ein Mädchen ist, dann freuen wir uns ganz besonders, weil da braucht man nämlich wirklich Nachwuchs, auch mit der richtigen Einstellung, mit ich will das machen und gib mir mal was zu tun und ich beweise mich daran.
Wir fragen direkt mal nach, Conny, bei den Schülerinnen, vor allen Dingen nach dieser Rolle. Ja.
Vielen Dank, Reinhold, für die Vorlage. Wir wissen ja, bis jetzt sind nur 10% aller Astronauten, also aller 400 Astronauten sind ja nur Frauen gewesen. Das kann ja mehr werden. Was fasziniert euch denn besonders am Weltraum? Franziska.
Ja, also es ist die Schwerelosigkeit und also wie die Astronauten damit fertig werden, was das für ein Gefühl für die sein muss, also kann ich mir schon toll vorstellen.
Ich meine, es werden auch weiterhin männliche Astronauten gefragt sein. Was würde euch denn daran Spaß machen?
Vor allem das Arbeiten im Weltraum. Nicht nur in der Raumfähre, sondern außerhalb der Raumfähre.
Also der Weltraumspaziergang, der dann mit Arbeit verbunden ist. Kannst du dir vorstellen, später mal Astronautin zu werden, so wie Claudie Enieret, die ja eine von den ESA-Astronautinnen war?
Also eher weniger. Also ich kann das nicht so haben, wenn ich mich so schnell fortbewegen muss, auch wenn ich dann ins Weltall fahre dann.
Also das ging ja noch ganz langsam, wenn man erstmal oben ist. Bis dahin hat man natürlich eine hohe Geschwindigkeit hinter sich gebracht. Und du, Sabrina, hast gefragt, ob Thomas Reiter Angst habe. So eine Frage sagt ja auch manchmal was über denjenigen, der die Frage stellt. Hättest du Angst?
Ich glaube schon, ja.
Warum?
Doch. Ja, wenn man da so schnell hochfliegt und dann, wie der Dr. Reiter gesagt hat, so in den Sitz gepresst wird, das stelle ich mir nicht so angenehm vor, ehrlich gesagt.
Wir haben jetzt gerade sowohl von Thomas Reiter gehört, als auch von Reinhold Ewald, dass natürlich ein naturwissenschaftliches Studium davor liegen musste oder ein Studium der Medizin. Kannst du dir, Christopher, vorstellen, ein solches Studium zu machen, um später mal möglicherweise Astronaut werden zu können?
Ehrlich gesagt weniger, weil ich bin auch nicht gerade so der Überflieger in der Klasse.
Kann ja noch kommen. Das muss ja nicht das Letzte sein. Franziska, nochmal, wenn du dir vorstellen würdest, vielleicht dann doch mal den Dreh zu kommen, denn ihr seid ja jetzt erst 13, das sind ja noch ein paar Jahre bis dahin. Was würdest du denn am liebsten machen? Würdest du gerne zum Mars fliegen, zum Mond fliegen?
Also wenn schon zum Mond, also beim Master, ich weiß nicht, da bin ich mir noch nicht sicher, aber...
Ist ein Stückchen länger, ne?
Ja.
Okay. Vielen, vielen Dank für euren Besuch hier in COL-CC, also im Columbus Control Center hier in Oberpfaffenhofen. Von Gilching aus war es nicht ganz so weit und Michael, zwischen uns beiden ist auch nicht so weit. Ich gebe das Mikro an dich weiter.
Ja, danke. Das war die erste Live-Schalte zu Thomas Reiter in den Weltraum hier aus Oberpfaffenhofen.
Discovery, Houston, are you ready for the event?
Houston Discovery, we're ready.
MSNBC, this is Houston Mission Control. Please call Discovery for a voice check.
Discovery ISS, this is MSNBC. How do you hear me?
MSNBC Discovery, we hear you loud and clear. We're ready for questions.
To be in contact. It's wonderful to see you up there looking healthy and well rested. I understand that you got to sleep a little bit more last night. Lisa, let me start with you because you entered the program back in August of 1996, almost 10 years ago. Was it worth the wait to go into space?
It was definitely a long wait, and it was definitely worth it. This is the trip of a lifetime. It's incredible up here. We've been real busy doing a lot of hard work, robotics for me especially. But today we had the chance to look around and see the beautiful view, take some pictures, and we got a tour of the space station, some parts we hadn't seen before, and it's thrilling to be up here.
The people who are launched into low Earth orbit, Lisa, get something that I guess the NASA doctors call space adaptation syndrome. In earthly terms, I guess that's nausea. How are you feeling now?
Yeah, the first day I was not feeling so great, and I guess that's pretty common. I've heard from people that come up here. And within a day after that, I started to adjust, and now I feel great. I can go into any of the modules and turn in any direction, and I'm completely adapted, and it's a lot of fun.
You missed the annual expedition with the Boy Scouts. That must be hard, given that you're a former Eagle Scout. What would you want to tell the kids back home about your experience so far?
With Boy Scout training I've had in the past, mattered a lot. We do the same kind of things. We practice it in small ways, we build it up, and then we get ready for the really big trip in the summertime. While I'm up here on the Space Shuttle back to the space station, we're going right overhead some Boy Scouts of mine that are backpacking in the mountains of New Mexico. You know, different trips, but the same kind of mentality. I think it's pretty awesome.
Kind of mentality, but seriously, you have got to have one of the most awesome, coolest jobs in the entire universe. You went on these spacewalks. I've talked to astronauts before what it's like when they first see the Earth and look out from the shuttle, but when you go outside the shuttle, can you even describe that experience, what it feels like and what you're seeing?
Sometimes I wish I was more of a poet than an engineer. Because the words just are not there to describe it. When I first went outside 6 days ago, it was night, so the world was inky, deep black. And in a way, that might have been better, because when you slip out of the airlock, all you see is the structure that looks kind of familiar. A little while later, the lights come on, you see the sunrise, and the light spreads across the globe underneath you as you're racing along. And it was beyond words to see the beauty of that. And of course, you really have to concentrate on doing your job and remembering that it's for real. And it's actually very dangerous and risky business. You've got to be very careful about what you're doing and pay attention to the details. So it's been pretty rare when we've had a chance to just sit back and take a look. I've had a couple of moments and enjoyed them a lot.
Pretty cool job, too, because you get to operate that robot arm, and those of us who have watched it from down here are just amazed at what can be done. But I have to believe there's also a lot of pressure. I mean, even NASA has described this, in the wake, of course, of the Columbia tragedy, as a make-or-break mission. When you're doing this very difficult, highly specialized work, do you feel the pressure?
Well, we received a lot of really good training on how to operate the robotic arm, and in Mike's case, how to do the EVAs, and of course we practiced on working together as a team. And sometimes it almost seemed like a simulation. Everything's going along as we plan, and then a little problem would come up, like they do in simulations, and we're well trained to adapt to all those changes. It's, of course, a very important mission, and we feel like we're getting the program back on track so all the missions after us can follow, and we're very happy about that.
Point out that back on track, because as you well know, there were a lot of people before you went up who questioned really the necessity of it, whether it was too dangerous for the shuttle, whether it was too dangerous for you and your 5 fellow crew members. And in fact, I know there were 2 major newspapers, the New York Times, the LA Times, who put editorials in saying things like the benefits gained from future flights are minimal, and suggesting that the shuttle program should stop now. What would you say to them, Mike?
I would say we have a commitment to the partners, our international partners, and to the American taxpayers who have a huge investment in the International Space Station. We're in this together. We're in it through the highs, we're in it through the lows, and we've learned that being in it together has been very healthy on a lot of different levels. But when we've had problems in respective programs, the other partners have been able to help out and help pull us through. We've got a commitment to them to finish this space station, to finish building it, to get it up to the full capability that we promised. And we really want to deliver that. And we do look forward to delivering that and getting the benefits from it and moving beyond.
I've talked to, Mike, going back to Gemini and Mercury, I've talked to those astronauts. They all say, look, they understand. They assume a certain amount of risk. You have a wife and 4 kids. Do you even think twice about doing this? Did you ever think twice about going up knowing the risk?
anybody that doesn't think at least twice about it doesn't really understand what's going on. Of course you do. You have to understand it. We've spent a lot of time. I've been in and out of NASA for a lot of years. A lot of the people that are managers now are my old friends, and they're making the decisions. They're working through those details, and I trust them with my life. And so if they look me in the eye and say, Mike, you know, we're good to go, then I can look my wife and my kids in the eye and I can tell them the same thing, that we're good to go, we're doing this safe and we're doing it smart. Yes, there's some risk involved, but there's some risk involved in driving across town too. Okay, there's a little more risk here, but it's a rational risk, and I think it's a needed risk, and I'm willing to take it.
Hearing from your friends and family back in Rockville, Maryland, Lisa, what would you want to say to them, both about the risk and about your experience?
Well, first of all, I have to say a big thank you because everyone's been supporting me a whole lot, both in the training period, which has been a couple years for us on this flight, and during the flight, we get some email and a chance to talk. We had our family conferences today, and it's been really nice having that kind of support. And I know that they all believe in this program too, and it's been listening on this 10-year journey while I'm been here at NASA, and they're in a way up here with me now too, and I think that's terrific.
A lot of students back in Montgomery County, Maryland, who are saying, wow, that looks amazing. How can I do that? What would you say to students?
Well, it's important to, of course, study hard and apply yourself and believe in your commitments and your goals. And you don't have to study one particular subject or do something you don't like because you think that's the right path. There's many different paths to get here. People major in many different things. The important thing is to pick an area you like and excel in that and believe in that. And those are the kind of people that turn out to be astronauts, and they come from all over the world.
Mike, wonderful talking to you. Thank you. Thank you, NASA.
Thank you very much, MSNBC.
CNN, Houston, please call Discovery ISS for a voice check.
Discovery ISS, this is Miles at CNN. How do you hear me?
Miles, we have you loud and clear, and we're ready for your questions.
Excellent. You guys are looking good. Well, first of all, let me introduce everybody to the crew as they hurtle above us, 200 miles above us, 17,500 miles an hour. Right here, there's the pilot, Mark Kelly. There's Pavel Vinogradov of the International Space Station, Jeff Williams of the International Space Station, Mike Fossum, spacewalker extraordinaire, Lisa Nowak, mission specialist, Stephanie Wilson, mission specialist, and Piers Sellers, the guy who lost his putty knife. We'll talk about that in just a few moments. But first of all, I want to talk to Mark Kelly about this problem we heard about the auxiliary power units. We hear you're looking at a couple of problems. That's a critical system. How concerned should we be about it?
Well, we do have a couple problems. Fortunately, we have three good APUs. They're pretty minor problems. We have three APUs, auxiliary power units for redundancy, and these are the things that generate the hydraulic power to power a flight control system. APU 1 has a small heater problem and a little loss of redundancy there, but we can take care of that by putting the shuttle in a certain attitude. And then APU 3 has a slight hydrazine or N2 leak, but it's pretty minor.
I want to ask you about this late inspection, which is coming up later today. Mark, you're going to actually look over the heat shield one more time because out of concern that Discovery might have been struck by a micrometeorite or some space debris. How big a risk is that, and how concerned should we be about that one?
Well, any spacecraft in orbit always has a certain amount of risk of being hit with something. I mean, there's a lot of objects in Earth orbit.
also things, micrometeorites that come from outside of the Earth's orbit. So there's always a possibility of contacting one of those. And by doing a late inspection, we mitigate that risk a little bit. We're going to inspect one wing today, and then tomorrow the nose cap and the other wing. And it'll slightly reduce our risk of damage to a thermal protection system. Or at least if the damage was to happen, we would know about it.
Why don't you float the microphone over to Piers, and we can talk about that issue of space junk for just a moment. You were out working on some techniques for repairing the leading edge of the wing, the reinforced carbon-carbon. I am a little curious about what happened to the putty knife, but I'm also more curious, really, how those tests seem to work.
Well, with regard to the putty knife, we have this big bag full of tools, and Mike and I take turns intending it, and of course it was my turn, so I've got no one to blame but myself. And while getting something in and out of the bag, I must have bumped the little hook that holds the action of the putty knife to my workstation. And when Mark went and looked at the movie later again, you can see the little guy making his escape, sneaking away between my feet later on, and he just crept away from me. I think he had been planning his escape for a while. In terms of repairs, the temperatures were a little colder than we expected, so Mike and I were working this stuff hard. It became kind of stiff pretty early. We would like to have seen warmer temperatures, but we think we did as good a repair test as we could, given the temperature conditions. And we're excited to see what the results will be when we get these back to Houston and test them under simulated entry conditions, see how they hold up.
Going to have to leave it at that, folks. We're out of time, unfortunately. We'd like to talk to you all, but we'll have to do that another time. Have a safe journey home.
Thanks, Miles. Great talking to you.
Discovery ISS, this is Houston ACR. That concludes the CNN portion of the event. Please stand by for a voice check from the NBC Today Show.
Discovery ISS, this is NBC News Today Show. This is Tom Costello. Do you copy?
Yeah, we have you loud and clear, Tom. How do you hear us?
I hear you fine. It's great to see you all. Mike and Piers, let me start with you. You all tested some repair techniques in space, and Piers, you lost a putty knife in the process. You contributed to some space junk up there. How did the process go? Do you feel like you've got this problem at all in hand? Trying to, I should say, patch a hole on the RCC.
Well, there's a part A and a part B to that question. Part A is, can you get the material out there and work it and apply it to the surface and cover the surface so it looks like a good repair? And can you use all the tools and work the material? I think we've answered that. The answer is yes, we can. Part B is, would that sample stand up to an entry? And we won't find that out until we get home and the guys in the lab run it through a simulated entry test and see how it stands up. So we're looking forward to seeing those results.
Mike Fossum, you have been with NASA for the better part of 25 years, and yet this is your first mission and your first 3 spacewalks. What was your impression as you first walked out of that hatch and you looked down below and you saw the Earth below you?
Tom, I have to say I wish I was part poet and not mostly engineer, because the words really escaped me. But it was, I mean, very gratifying. I've been around, been in and out of Johnson Space Center since the very early days of the Shuttle program, and dreamed about doing this for a long time. So it was, very gratifying. At the other hand, it wasn't about me. It was about getting the job done, and I'm just very fortunate to have the opportunity to do my part to contribute, and was excited to do so, no doubt.
Yeah, Lisa and Stephanie, both of you have been with NASA for the better part of 10 years. You've waited an eternity to finally fly in space, and now that you're there, what are the first impressions, or what are the gee whiz factors that you didn't expect that suddenly you're looking at?
Well,
Well, of course, the view is breathtaking up here, and we've been told about it, but it's experiencing it is something else. It's just incredible. And as far as something we didn't quite expect, for me, the light and dark cycles as they change are quite dramatic, but it has a big effect when we do our robotic operations. Sometimes we are looking at a critical clearance view, and all of a sudden it goes to darkness, and you have to adjust and use other cameras. And it's something we had to learn as we were here, and I guess we received real good training on how to do that. And for me, one item that I expected to be fun and certainly turned out to be even more of a key was just floating through the space station and seeing all of the modules and all of the work that the previous crews and the current crew has done here.
To Jeff Williams, you have been on the space station for some time. What do you miss the most when you're up there for 3, 4, 5, 6 months? Do you miss soda? Is it beer? Is it a football game? What do you miss when you're up there for so long?
Well, I think the answer is obvious. The thing I miss the most is my family, in particular my wife, who is at home also waiting the 4, 5, 6 months or more. So she's the one that I miss the most.
Mark Kelly, you were about to bring Discovery back as a pilot. Do you feel like she's clean? All indications so far are that she is clean. And does that indicate that the shuttle is, in fact, back to a normal type of delivery? You can fly it safely from here on out.
Based on what we've seen over the last 10 days, the inspections we've done, the data the ground's analyzed, we've got a great ship. It's ready to come home. We're going to be doing that on Monday morning, and it's going to be a safe landing, hopefully at the Kennedy Space Center if the weather's good. So, the space shuttle's ready to go, and after this flight, I think we're really in a good configuration, and we're pretty much set up to continue assembly of the space station and continue to fly the shuttle, hopefully like we did before 2003.
Thank you all. Safe trips home. Thank you.
Thank you, Tom.
Discovery ISS. This is Houston ACR. That concludes the NBC Today Show portion of the event. Please stand by for a voice check from ABC News.
Discovery ISS, this is John Burnett at ABC News. Do you hear me okay?
Yeah, John, we have you loud and clear.
I guess my first question is for Lisa. It's flight day 11. You've been up there for quite a long time. Do you ever get sick of each other? Be honest.
Well, actually, getting along pretty good. As we get to the last few days, if we start running out of food, that story might change. But so far, we're doing pretty well.
What's the most gratifying thing about being up there right now? Do you really think the shuttle program has turned a corner now?
Yes, I do. This flight and the one last summer, we were together to return to flight missions, and we feel like we've done all the tests and met the objectives, and we feel like the whole program is back on track for us to assemble the space station and move on back to the moon and to Mars, and we're looking forward to all of that.
All right, now I have a question for Mark Kelly. Mark, you were woken up to ABBA the other day. Apparently your daughters chose an ABBA song. What was that like to hear ABBA in outer space, and what do you make of these wake-up calls altogether?
Well, the interesting thing is Claudia and Claire don't even really know who ABBA is, but they really like that song just from the Mamma Mia musical. So that's some of their favorite music. And it was okay with me. I think ABBA might have annoyed some of my other crew members, but certainly not as bad as what we had to wake up to this morning, which would not stop, which was the 2 minutes of the Aggie fight song.
Was Mike singing along to the fight song this morning?
Well, I was sleeping up on the flight deck, but I did hear some noise. I can't say it was quite singing.
All right, I have a question for Piers Sellers. Piers, are you going to buy NASA a new putty knife?
I will get them the very best that Home Depot can offer.
In all seriousness,
I'm sure it'll come out of my pay.
in all seriousness, one of the things you will be doing today is examining the shuttle's underbelly and in port side for hits by micrometeorites. How much of a risk are these, and does the flying spatula represent a new risk?
Well, the spatula doesn't represent a risk because we know where it is, and it's gone, and it's moving very slowly relative to the shuttle. So that's not a threat, but Stephanie can tell you about the micrometeorites.
Well, yes, later today we'll be doing an inspection of the port wing to look for on-orbit debris or impacts, and we'll do that while we're docked, and when we undock, we'll inspect the nose cap and the starboard wing. So we still have those inspections and that activity to do. We'll be able to see the data on board, and of course we'll downlink it, and so the ground teams will have a chance to analyze the data.
And how much of a risk are these micrometeorites?
We don't really know what the risk is. It's pretty low. We've been flying space shuttles for a long time, and we've never had any kind of critical damage from a micrometeorite. So it's pretty remote.
Just back to Stephanie. Stephanie, it's your first flight. Given everything the shuttle program has been through, and I guess in light of the successful inspections, how do you feel heading into landing?
Well, it's feeling pretty good. We've had 11 days to be on orbit and to adapt to space and have a chance to work with our friends on the International Space Station. And I'm looking forward to returning home and spending some time with friends and family.
Piers and Mike, you were testing some in-flight repair techniques. How did it go, and do you think you're now at a place where you could make in-flight repairs if you had to?
I think we've cleared a couple of major hurdles. On our first EVA, we've proved that the boom, the OBSS on the shuttle's arm appears to have the stability required to allow you to make repairs out to places like the wing that are very slick. You don't have anything to hang on to and need a way to get there and stabilize. So that was a very positive test. A couple of days ago on EVA-3, when we were doing the NOAX repair, the RCC repair, we'll need to get those samples back to the ground and run them through the test back home. But from our perspective, from the operator's perspective up here, your ability to manipulate the materials, get it worked down, and do the kind of patch job that would be required looks like it is very doable under the right thermal conditions and stuff. We just need to test it in the high temperature facility to make sure that it holds up.
All right, thanks guys very much, and good luck.
Thank you, John.
Discovery ISS, this is Houston ACR. That concludes the ABC News portion of the event. Please stand by for a voice check from CBS News.
Discovery ISS, this is Bill Harwood at the Johnson Space Center. How do you hear me?
We hear you really well, Bill. Can you hear us?
Loud and clear, and let me start with Mark Kelly. I realize that the mission's not over yet, but how do you rate the success of the flight so far, and how confident are you that NASA's finally turned the corner on its recovery from the Columbia accident?
Well, we're getting close to meeting all our mission objectives. Our commander, Steve Lindsay, right now, about 30 feet behind us, is closing out the logistics module. So we've completed all the transfer, we've completed all the objectives with our 3 EVAs. The Space Shuttle Discovery is in great shape for a return trip home on Monday. We've got a little extra work to do with some late inspection. We have the undocking coming up tomorrow and moving the logistics module into the payload bay today. So we're really in good shape to come home.
Thanks. And for Mike Fawcett, let me ask you the same question. Is NASA finally ready to shift the focus, I guess, from recovery and return to flight to space station assembly?
Well, we hope so, Bill. We needed this mission to get a lot of these objectives, test the ability to do some of our own, or reinforce our ability to do our own inspection, test our ability to get access to different places on the shuttle's wing and underbelly if we needed to get there to do repairs, and we've done some testing on, future repair capability. So we're feeling good about that. We've answered a lot of those questions almost completely, and I think we're ready to get rolling.
Thanks, and one for Pierre Sellers. Before Columbia, NASA managers used to warn us about what they called the wall of EVA that was coming, and I guess now that you guys are poised to really resume assembly, that wall is here. How difficult is the EVA task that are facing you guys in the coming months as you build out the truss?
Well, there's really a lot to be done. It is kind of a wall. It's a little mini Himalayas, I guess. Every flight has got to get through its EVA tasks and install its equipment before the next flight that can go. I mean, that's really the way the sequence works. So it's going to be a lot of hard work. It's a lot of hard work with a lot of people on the ground working furiously to make this happen.
Thanks, and let me ask one to Lisa and Stephanie. The execute package today calls you guys the Robo chicks. I got a big kick out of that. Obviously, robotic arm operations are a major factor in all of this. What's the learning curve like, and will you be able to do late inspection perhaps more efficiently than right out of the box when you launched?
Yes, we've actually learned a lot while we've been up here. We received great training for a couple years before we came. There's some things that we just couldn't quite train on the ground, like learning just how dark it gets when the sun goes down and adjusting with different cameras. We were told we had to do that, but it was dramatic, just how dark it got and how quickly we needed to bring up other views. The late inspection, it's basically the same procedures, except the port wing will be doing that docked. Which wasn't the case before, but we think it'll probably go a little more efficiently this time.
Thanks. And for any of you, how do you all look at the risk of MMOD? I mean, if you think about main engines and the kind of risk that you normally accept for a flight anyway, where does MMOD fit in your minds, risk-wise?
It is more remote than asset debris, and so it is a risk. Since we are doing the inspection, it's something we want to find out and determine before we enter, but it's considered to be of lower risk than some of the other items that we consider.
For some of you, I guess this is probably your last space flight. I don't know, that sounds depressing, but I guess that's just the reality of it. I mean, I was wondering if any of you thought about that while you've been up there and tried to kind of lock in the memory of this experience before you come back.
Well, I don't think that's the case for any of us. We're all ready to go, and we're all hoping to get assigned to another mission, and we've enjoyed this a lot. And so, I don't know if I can speak for everybody else, but what do I get an agreement here from you? We're all ready to go again.
Hey, thanks. I got to squeeze in one last quick one. Mark, how confident are you guys about reentry in the state of your heat shield? I know it's a clean ship, but maybe just some final thoughts here. Thanks.
Yeah, we're real confident. I mean, we're going to look at it one more time, but based on what we've seen so far and what the risk is, I think all of us feel really comfortable. I was looking out the window the other day and looking down both wings, and they're looking like they're in great shape, similar to when we saw them when the orbiter was being processed. So you can't see everything come out the window. That's why we're going to do some more inspection today and tomorrow.
Thanks a lot, and have a safe trip back.
Thank you. Appreciate it.
Discovery ISS, this is Houston ACR. That concludes the event. Thanks.
Thank you.
And on behalf of Pavel, I would like to welcome you all on board Expedition 13, and thank you for the great work that all the teams have done in all the control centers to do several things for us. One was, of course, to get the shuttle off the launch pad and the crew safely up here, to resupply us, as well as to take home a lot of trash and garbage. Also to get Tomas up here to join us on Expedition 13, which we've been waiting a long time. The mission, the EVAs, the robotics, the transfer, everything went very smooth, and it's because of the team on the ground. So that's why we wanted to bring you all on board tonight and have you join us for a meal. It's all the planning that you did and the execution and the real-time planning, the amazing work that you did turning it around every day. We really appreciate it, so we welcome you on board. Thank you all.
And
And Jeff, thank you for those words. Actually, the plan would never work if there weren't anybody to execute that plan. And surely the crew of Expedition 13 during docked operation with STS-121 will surely go down in history as being one of the most efficient crew ISS has ever seen. So congratulations to you all. And Steph, we're looking at you now. You were hidden behind Steve Lindsay and we couldn't see you. If you see the camera, if you move a little bit up, then you'll be in the picture. Or Steve down, what a good idea. Thank you for the invitation for dinner. We're so happy to be with you, and maybe you can give us a bit of commentary on where you are, and also we're not sure we're seeing any food here.
Well, we're going to get the food out as soon as we get the formalities over with, and then what I'll do is I'll pass the headset around, and folks just sit there a minute or two each. How's that?
Great idea.
All right. Enjoy dinner.
Hi, this is Steve Lindsay, Commander 121, and Jeff and Pavel and Tomas have been gracious enough to invite us over for yet another meal. We're looking forward to eating the food. It's great to be live talking to you guys. Both the control centers, actually all the control centers. I'd like to thanks for. I know we got 3 or 4 tough days left to go, but for all the work, both the ISS and the shuttle control teams, the Moscow teams, and Huntsville have all done for us, pull this mission off and make it as successful as it is. Couldn't do it without you. So, and thanks to the Expedition 13 on board. And when a shuttle mission comes up, we're kind of like a hurricane. They're in a science. They're doing a lot of good work. Come on board. We're not real adept. Have tons of stuff on board. Scatter it all over the station. Poor Jeff and Pavel Tomas had to clean up after us every day and secure all those bags that we left floating and didn't get them secured just right. He's laughing, but he knows what I mean. And and never got upset. He's even keeled and let us bang around. Probably laughed at us a little bit, rightly so. But so privileged to work with them as a key to this mission is a team, not only on the ground but also our together into one. All you on the ground and
Thank you, Steve. Very nice words.
I guess I'll be the next. They all pointed to me, so I also would like to take the opportunity and thank you all very much for all this preparation. It was really great pleasure to be part of the 121 crew. They really welcomed me, made me a part of their crew, got me up here safely and really made me part of their group, and I really enjoyed this time with them very much. It will be a sad moment when they will be leaving. Of course, on the other side, I'm looking forward to get in a kind of routine together with Jeff and Pavel, and I also would like to extend my greetings and my thanks to all the training teams that prepared us. Especially I have to say that in the last days where I was mainly busy with the transfer, the plan was perfect. Just was carrying out the plan. It made it so easy for us to do all these transfers back and forth, get the items in the station, load up the MPLM by just following this plan, and I think this is remarkable. Now I'm looking forward to be together with Jeff and Pavel to work on the station, and I wish you all the best, and I'm looking forward to work together with you.
And Tomas, we copy. Thank you. The training team in particular will very much appreciate those words, but I can tell you that the guys who are in 7th heaven right now, I think even higher than you are the entire ACO and transfer team, because it's been such an easy transfer, packing, unpacking, and that's due, one, to the formidable pre-pack work that Pavel and Jeff have done, your training, your planning, but first and foremost, your organization and efficiency. Thank you very much.
Окей. Я хочу поблагодарить все смены центров управления полетов. Хочу сказать огромное спасибо всем, кто нас готовил, кто нас готовил к этому полету. И поверьте, мы постарались сделать все, как вы нас учили, даже лучше. Спасибо вам за это. Мы с удовольствием делали всю нашу программу. И сегодня у нас такой заключительный вечер. Мы с некоторой грустью расстаемся с нашими друзьями, экипажем Discovery. Мы желаем им мягкой посадки. Мы желаем их еще многих-многих полетов. И Лизе, и Стефани, чтобы это их начало продолжалось долго-долго. Спасибо всем за поддержку и за работу.
Hey, Julie, we're going to take a little break here for food and going to dive into the bellied eels. Back with you in just a sec. By the way, Thomas Ryder is an imposter. I'm Thomas Ryder, and I'll be staying.
Copy that.
Hi, Julie.
Hello, Pierce.
Hi, any of the EVA team still there, or are they all sleeping it off?
Keith is here, but let me check.
Thanks.
And Pierce, we have backroom EVA plus Keith. And Corina.
And Corina. Well, I would like to say in front of witnesses that we love all you guys and gals. You have put up with us whining and groaning for the last 2 years from the NBL, but you trained us nonetheless, and you put together this magnificent plan, constantly changing set of tasks. March, and then Karina has put together this tools management plan that actually worked. Fantastic, it really did work, and you managed to get us through 3 complicated EVAs with all this stuff, and we're in awe. So we decided that between Mike and I, we're going to buy each of you a beer when we get back. Okay, all right. We're going to do a lot more. We're going to do something very, very nice for you. But we love you all. We wish you were here with us. I mean, that's my biggest threat here. I wish you guys and gals up here and you be with us and see this too. Something. So, hey, Julie, is anyone listening to that, or they leave?
We're all speechless because of those words. Everybody was listening, and Pierce, we will make an MPEG file of that and make sure that those that were at home sleeping because they've been working the overnight shift will also hear them.
That's great. I talked to Thomas today on his cell phone, but I couldn't tell if he was at home or in hospital.
Well, he did go in briefly during EVA too, but he's since come back in.
Yeah, I know. Well, I'm sorry we made life so rough for everybody down there during EVA. I mean, yeah, things stacked up.
through it, like having a couple of guardian angels, right? So thanks a lot. We look forward to seeing you very soon. Lots of love. Bye.
Thank you.
Julie, how are you?
Hey, we're doing great. It's great. We send out the invitation to dinner to the rest of the office and out there so people could watch you.
Oh, that's nice. Did you think you got some takers?
Well, your brother said he was too busy in a sim.
Too busy in a sim. That's not a good excuse. Hey, how was the launch?
Well, for those who got to see it, I was at Mission Control already, but those who got to see it said it was absolutely phenomenal because it was clear blue sky, absolutely gorgeous weather. The 4th of July, awesome.
That's great. We weren't quite sure if what the view was like from the causeway and from Banana Creek when we actually lifted off. We were talking about it a couple hours before. So we're glad to hear it. Looked from the pictures we saw, it looked great.
No, it was really spectacular, and from what I understand, because of the blue sky, when white plume just goes away, it was fantastic. You'll get, I'm sure, a picture of the launch from every single relative and friend that was there.
Yeah, well, that's great. We also saw that video at SR of the orbiter and the tank peeling away. That was great.
Isn't it awesome? Hey, some of the flight controllers here were curious about the Russian food. Maybe Jeff, Pavel, those familiar with it, could let us know what's in those tin cans.
The tin cans, well, they actually, fortunately, have both, well, except for this one, which was, this is basically cranberry sauce, which is really good. All of it is really excellent. But so far we've had beef with vegetables. We've had some cheese, some really, really good mashed potatoes are great. Some lamb with vegetables, some hike and perch, something called appetizing appetizer, which is just the way it's translated, but it's really good, and some pork with vegetables, and I think, personally, and I mean, coming over from the orbiter after, a few days of orbiter food, it's really nice to have some of the Russian food. It's really good.
Awesome. Thanks a lot. That's really helpful. And Jeff, we saw that. Good catch.
Saw your catch. We also have here some pepper, which is some pretty hot stuff. You wouldn't, according to Jeff, you don't want to get it in your eye. Mike's been putting this on just about everything, being the Texan that he is. And then the Tabasco soy sauce that I think Jeff keeps for himself.
Der Weltraum in faszinierenden Bildern. In 400 Kilometer Höhe umkreist die Weltraumstation ISS die Erde. Nachdem die Astronauten zunächst mit dem Andock-Manöver, ersten Schaltgesprächen mit der Erde und 3 Ausstiegen aus der Raumstation spektakuläre Aktionen durchgeführt haben, bereiten sie sich nun auf die Abkopplung des Shuttle vor, das am Montag zur Erde zurückkehren wird. Dann wird aufgeräumt und umgepackt, bevor sich Thomas Reiter auf seine wissenschaftliche Arbeit an Bord konzentrieren kann. Ja, schönen guten Abend, meine Damen und Herren. Wir hatten Gelegenheit, mit Thomas Reiter diese Woche zum ersten Mal zu sprechen. Eine direkte Schalte von Phoenix in den Weltraum, das war sicherlich das Highlight dieser Woche. Wir werden Ihnen gleich darüber noch einmal Bilder zeigen und die wichtigsten Ausschnitte natürlich zeigen. Er ist sehr gut gelaunt, muss man den Eindruck haben. Sie werden das gleich sehen. Ich bin hier in Oberpfaffenhofen bei dem Kontrollzentrum und habe den stellvertretenden Leiter Dieter Sabat neben mir. Wir wollen ein bisschen sprechen, danke, dass Sie bei uns sind, über die Arbeit, die Sie hier machen und auch über das, was wir diese Woche erlebt haben. Herr Sabat, was waren für Sie die Highlights diese Woche?
Ja, ganz klar, die Highlights waren die 3 Ausstiege aus dem Shuttle zur einmal Reparatur dieses mobilen Plattform auf der ISS, dann die Probe, ob man Kacheln reparieren kann auf der Raumstation und einige Umbauten, die auf der Raumstation durchgeführt wurden. Das ist natürlich das Highlight dieser Woche gewesen. Der Thomas Reiter hat ja auch den Astronauten geholfen beim Einsteigen in die Raumanzüge, hat sich daran beteiligt. Seine Hauptaufgabe war natürlich das Modul auszuladen, mit dem die Nachschub an die Raumstation gebracht wurde.
Wir sind hier im Columbus-Kontrollzentrum in Oberpfaffenhofen bei München. Sie sind stellvertretender Leiter, habe ich eben gesagt. Und dann können Sie uns auch noch mal erklären, was Sie hier genau machen.
Ja, ich bin der Projektleiter für das Operations-Team hier am Columbus-Kontrollzentrum. Und wir sind hier verantwortlich für die Koordinierung der Experimente, die Thomas Reiter durchführt an der Raumstation. Das heißt, wir koordinieren die Ablauf der Experimente, der europäischen Experimente, zusammen mit den europäischen Nutzerzentren, die in ganz Europa verteilt sind.
Und die wissenschaftliche Arbeit, die hat schon so ein bisschen begonnen, aber die geht jetzt so richtig los, wenn das Shuttle abgelegt hat.
Ja, das ist richtig. Also während der Shuttle-Phase war die, wie ich schon gesagt habe, die Hauptaufgabe von Thomas Reiter in dem Ausladen des Nachschubs. Und er hat auch schon gestern die ersten Experimente durchgeführt. Und das wird jetzt natürlich neben seiner Arbeit für die ISS, Unterhalt und Reparatur, einer seiner Hauptaufgaben in den nächsten Monaten werden. Und da sind wir natürlich dann sehr umfangreich beteiligt.
So, und wir wollen den Zuschauern natürlich auf jeden Fall mal präsentieren, was Thomas Reiter gesagt hat, wie die Situation war, wie die Laune der Crew an Bord war und deswegen hier Ausschnitte aus der sozusagen Konferenz, die Thomas Reiter und 2 Kollegen gemacht haben, direkt aus dem Weltraum hier mit Phoenix.
Okay, herzliche Grüße von der Internationalen Raumstation. Wir fliegen hier gerade über den Südpazifik. Das heißt, wenn wir jetzt aus dem Fenster schauen, gibt es außer Wasser leider im Moment nicht viel zu sehen. Ansonsten kann man hier im Hintergrund das amerikanische Lab sehen, in dem wir uns gerade aufhalten. Zusammen mit mir ist unser Kommandant Pavel Vinogradov und der erste Bordingenieur Jeff Williams mit mir hier. Und ich werde dann einige der Fragen, die jetzt kommen, dann an die beiden natürlich weitergeben. Und wir sind jetzt bereit, die ersten Fragen zu beantworten. Bitte schön.
Herr Dr. Reiter, warum sind Sie für 6 Monate zur ISS geflogen?
Ja, also an Bord scheint beste Laune zu herrschen und ich glaube, die Kinder, die hier waren, haben es auch genossen und ich denke, der ein oder andere wird sich vielleicht wirklich überlegen, ob er was mit Weltraum zu tun haben will. Herr Sabat, jetzt haben wir natürlich auf unserer Seite phoenix.de eine ganze Menge an Zuschaueranfragen und wir wollen darauf eingehen, weil das ein unglaublich komplexes Thema ist, die Weltraumfahrt. Zum Beispiel Sabine Kaiser aus Schwetzingen fragt, mich würde brennend interessieren, warum die Astronauten die Geschwindigkeit, mit der sie sich im All fortbewegen, gar nicht wahrnehmen, nicht einmal während des Weltraumspaziergangs.
Ja, die Astronauten nehmen die Beschleunigung wahr, mit der sie beim Shuttle-Start auf diese Geschwindigkeit gebracht wurden. Da wurden sie zum Beispiel mit 3-facher Erdbeschleunigung in die Sitze gepresst. Und das ist wahrnehmbar. Während die reine Geschwindigkeit in der Erdumlaufbahn, die nimmt man nicht wahr, vor allem deshalb, weil es im luftleeren Raum geschieht. Das heißt, während der Radfahrt oder im Auto kann man bei konstanter Geschwindigkeit die Luft spüren, die vorbeizieht. Aber das ist ja im Weltraum nicht der Fall. Es ist ja fast nahezu luftleerer Raum und deswegen kann man die Geschwindigkeit nicht spüren, wenn man sich auch außerhalb der Raumstation sich befindet.
So, und Herr Rainer Lackner aus Königstein fragt, wäre es theoretisch möglich, mit einem Shuttle bis zum Mond zu fliegen? Nicht dort zu landen, sondern nur diese Strecke zu fliegen. Mit genug Proviant müsste es doch theoretisch gehen. Warum hat daran die NASA nie gedacht?
Daran hat die NASA deswegen nicht gedacht, weil es von technisch nicht möglich ist. Das Shuttle kann eine maximale Höhe über der Erdoberfläche von ca. 600 Kilometern erreichen. Das ist ungefähr die Höhe, in der das Hubble Space Teleskop sich befindet. Das ist die größte Höhe, die das Shuttle jemals erreicht hat. Darüber hinaus bräuchte das Shuttle so viel Treibstoff, um eine größere Höhe zu erreichen, die es einfach nicht mitnehmen kann.
Und Arne Lampmann fragt, wenn man dort oben Freizeit hat, was macht man denn da überhaupt? Auch in der Schalte haben wir dazu was erfahren. Man guckt am liebsten auf die Erde, hat Thomas Reiter gesagt. Aber was kriegen die für Informationen da oben? Haben die den Fußball zum Beispiel sehen können? Bekommen die Informationen über das aktuelle Geschehen auf der Erde und wie?
Ja, Sie können E-Mails bekommen, aber nur von ausgewählten E-Mail-Sendern. Sie bekommen natürlich regelmäßig auch von Ihren private Post nach oben, also elektronisch natürlich. Und wenn ein neues Fahrzeug kommt, eine Soyuz oder eine Shuttle-Mission, wird auch dann was mitgesandt für die Astronauten. In der Freizeit, die normalerweise Wochenende ist Freizeit, das heißt, da haben sie nichts zu tun. Shuttle-Zeiten sind Ausnahmezeiten, weil das immer ein sehr enger Zeitplan ist. Da wird dann auch mal am Wochenende gearbeitet. Zu normalen ISS-Zeiten ohne angedocktes Raumfahrzeug wird am Wochenende ist Freizeit und die Astronauten können nach ihrem eigenen Interesse ihren Beschäftigungen nachgehen. Und wie gesagt, Thomas Reiter hat ja erzählt, er sitzt sich gerne ans Fenster, nimmt vielleicht auch mal eine Gitarre zur Hand und spielt...
Wenn er die Seite endlich wiederfindet.
Ja. Wenn er es machen kann, ja, tut das gerne. Und dann ist natürlich, das ist ein Blick, der ist umwerfend, der kann einem auch nach stundenlanger Betrachtung nicht langweilig werden. Diesen Ausblick hat man eben nur von da oben, von der Internationalen Raumstation.
Dieser Sabbat, ganz herzlichen Dank für Ihre Erläuterung. Wir sehen uns ja in regelmäßigen Abständen wieder. Dankeschön. Ja, meine Damen und Herren, und was da oben auf der ISS passiert, das haben wir jetzt erfahren. Aber wie diese ISS funktioniert und was die Idee dieser ISS ist, das haben wir in einem kurzen Erklärstück zusammengefasst.
In 90 Minuten um die Welt. Die Internationale Raumstation, kurz ISS, zieht rund 400 Kilometer über uns ihre Bahn. Sie ist modular aufgebaut, das heißt aus einzelnen Teilen zusammengesetzt. Einmal fertiggestellt, wird die ISS um ein Vielfaches größer sein als die legendäre Mir. Seit November 98 bauen 16 Nationen an dieser größten von Menschenhand erschaffenen Baustelle im All. Da es nicht möglich ist, größere Bauteile komplett in den Orbit zu bringen, werden rund 100 Konstruktionselemente erst nach oben befördert und dann im All zusammengefügt. Auch heute ist die ISS längst noch nicht fertig. Weitere Module warten auf der Erde auf ihren Einsatz. Geplant sind in der letzten Ausbaustufe 6 Forschungsmodule, hier ein Modell der NASA, 2 Wohnkomplexe und Versorgungseinheiten. Das Ende der Bauzeit steht noch in den Sternen, denn die hängt vor allem von den Shuttleflügen ab, die die Internationale Raumstation versorgen. Wasser und Luft werden hier an Bord zwar weitgehend wieder aufbereitet und recycelt, die Nahrung für die Astronauten allerdings muss nach wie vor von der Erde mitgebracht werden. Ab jetzt wird die Internationale Raumstation mit Thomas Reiter 3 Dauerbewohner beherbergen. Deren Aufgabe ist es zu forschen, aber auch die ISS zu warten, innen sowie außen, damit alle Systeme weiterhin einwandfrei funktionieren. 6 bis 8 Stunden können Thomas Reiter und seine Kollegen an der Außenseite der Raumstation werkeln, dann müssen sie wieder hinein. Ihr Hightech-Arbeitsplatz bringt den Astronauten in den nächsten Monaten einen anstrengenden Alltag. Aber sie haben garantiert eine Aussicht, die ist außerirdisch schön.
Meine Damen und Herren, das war Alltag, die Thomas-Reiter-Mission von uns beobachtet, regelmäßig Montag, Mittwoch und Freitag und am Samstag. Und wir haben heute, glaube ich, eine sehr spannende Woche gehabt und diese Zusammenfassung Ihnen präsentieren können. Ich hoffe, es war von Ihrem Interesse. Und wenn Sie weiter Interesse haben, auch an bestimmten Fragen, scheuen Sie sich nicht, melden Sie sich unter phoenix.de. Da sammeln wir die Zuschauerfragen. Schicken Sie uns eine Mail und wir werden bemüht sein, diese Mails zu beantworten. Das war's für heute Abend. Herzlichen Dank für Ihr Interesse. Tschüss.
Good morning, Discovery. Mike, we hope you enjoyed that. I'm not sure about the rest of the crew, but it was from Melania and all the other Aggies around the globe.
Giga Maggies, thanks, Steve, and thanks to my lovely Aggie wife, Milani, and most of our family and many friends for setting that up today.
Hey, you're welcome. You know, Mike, there are quite a few Aggies right here in Mission Control and all throughout Texas who've been watching what you've been doing intently during this mission. And so much so, I think you could even say the eyes of Texas are upon you.
Ooh, I'm not sure I like the tone of that.
That was for Stephanie.
Now she's admitting she's awake.
Sounds good.
In this live view from the International Space Station, we see the crew working on closing out the multi-purpose logistics module before it is removed from its attach point at the Unity node on the station. Now the crew installing a thermal blanket onto the module itself. This is a live view inside the Destiny Laboratory module aboard the International Space Station with shuttle astronauts Lisa Nowak in the background and Stephanie Wilson in the foreground, setting up at the robotics workstation to operate the space station's robotic arm, Canadarm2, and use it to uninstall the multi-purpose logistics module, the Leonardo cargo module that brought supplies to the station and is returning unneeded equipment and hardware from the station to Earth. And that module will be placed back inside Discovery's cargo bay today.
And the robotics officer in the International Space Station control room reports that the crew has completed a good grapple of the Leonardo multi-purpose logistics module.
This is Mission Control Houston as we continue to watch these live downlink television pictures of the Leonardo multi-purpose logistics module, now grappled by the space station's robotic arm as Stephanie Wilson and Lisa Nowak operate the controls for the arm from inside the Destiny Laboratory at the robotics workstation. Here we can see on the left the two spacewalkers, Piers Sellers, and behind him Mike Fossum, operating the commands for the bolts that are holding Leonardo modules to the International Space Station. On the right are Stephanie Wilson in the foreground and Lisa Nowak in the background, operating the robotic arm for the station known as Canadarm2 from the robotics workstation as they move through this procedure to unberth the Leonardo cargo carrier from the Unity module's Earth-facing common berthing mechanism port. So far, the crew has managed to drive the first two sets of mating bolts into the open position. That means that 8 of the 16 bolts that need to be opened have been released. And the third set of those bolts, another 4, is in work.
This is Mission Control Houston. Welcome back to live coverage of the uninstallation of the Leonardo multi-purpose logistics module from the Unity module of the International Space Station. This is a sequential still video picture of Leonardo as it is in the uninstall clear position. And here's a look inside the Destiny Laboratory module as Lisa Nowak and Stephanie Wilson on the right there at the robotics workstation continue to maneuver Canadarm2 with the Leonardo module on the end of the structure.
And here's a look outside the International Space Station at Leonardo, poised above the
Unity module and with the robotic arm grappled to the power and data grapple fixture on the Destiny Lab module. To the left is the Soyuz spacecraft that Pavel Vinogradov and Jeff Williams rode up to the International Space Station 3 months ago. These views with the northern coast of France in the background as the shuttle station complex orbits 211 miles above. So far, everything going very well with this unberthing procedure. The Attitude, Determination, and Control Officer in the International Space Station Flight Control Room so far seeing acceptable changes in the momentum management so that these activities so far don't look like they're going to have to be moved over to the vernier or fine rates of the robotic arm. Crew proceeding with the nominal procedure for rebirthing Leonardo in Discovery's cargo bay.
We'll search at 50 past the hour. So we'll wait 15 minutes or take your go.
Station Houston, Jeff, we copy and concur, and it will be a 15-minute wait for that. Also, while I have you, we confirm that the CBM pedals are closed.
Roger, thank you.
And this is Mission Control Houston. Jeff Williams, the flight engineer for Expedition 13 aboard the International Space Station, reporting that he's in the process of finishing a gaseous nitrogen transfer. As part of his activities today, he's going to be stopping the transfer of that atmospheric component along with tearing down the oxygen transfer hoses. Space Station Commander Paul Van Grava, meanwhile working with the maintenance of the common berthing mechanism. While spacewalker Piers Sellers and pilot Mark Kelly are about to begin their work with the EVA tools management in the Quest airlock module of the space station.
Good afternoon and welcome back to NASA's Johnson Space Center for today's STS-121 ULF 1.1 mission status briefing. We have both lead flight directors here with us today to give us status. For Shuttle, it's Tony Focacci, and for Station, it's Rick LeBrode. So we'll open up with comments and then take questions. Tony?
Okay, good morning everyone. See, after a well-deserved day off yesterday, the crew hit the ground running again today as part of the 121 mission. We did a bunch of MPLM activities to get ready to berth it in the payload bay, and I'll let Rick talk the details of that. Of course, after we get the MPLM installed, the crew has to go ahead and have to walk off the station robotic arm over onto the mobile base system, and that's basically to get us configured and set up to do late inspection this afternoon. And the late inspection they'll be doing this evening is the port inspection. And after they get that completed, the crew will put the shuttle robotic arm with the OBSS on it in the handoff position, get ready for undock tomorrow. After the inspection ops, the crew will be doing the rendezvous tool checkout and prep for undock tomorrow. And also, let's see, the undock, I think you guys probably all have this, but is at an MET of 10:15:30, which is about 5:07 in the morning Central Time. And what I have a special treat for you, I don't know if you've seen these yet, but some of the IR videos and pictures that the crew took on EVA number 3. So I think the first one we're going to see is just a still photo of the two samples. You can see the different thermal characteristics on these two tiles. And this is what we hope is going to give us a new sensor capability to detect damage on the reinforced carbon-carbon panels. And you probably see when we were looking at the sample box, was it Thursday? I don't even know, EVA 3, whatever, a couple of days ago it was. You could see that you didn't see anything on these, but basically what they've done, the damage was in the inside of the samples, kind of like you'd be looking for delamination if you had an essence debris hit or a micrometeorite hit. So kind of shows the reflections and the damages that they did put in those samples. So the next one, we're going to show a quick video that Mike took of Piers while he was working. That's pretty neat. You can see where all the how hard he's working in his hands, how hot they are, and probably with his gloves on, and some of the, you know, there is some leakage in the suits, and you can kind of see that a little bit with the thermal. Pretty neat looking. I saw that this morning, and I thought maybe you guys might enjoy that. Seeing with that, I'll hand it over to Rick for the station side of the house.
All right. Thanks, Tony. Good morning, everyone. As Tony said, the crew is in the process of removing the MPLM from the station and putting it back in the shuttle payload bay. When Tony and I walked over here, the crew had already grappled the MPLM. They had completed the leak checks of the vestibule before they uninstall it. And so very shortly they ought to be unbolting it and then moving it into the shuttle payload bay. That is pretty much we're coming to an end on ISS activities for the mission with the planned undocking tomorrow. This is going to be my last shift. The mission has gone just outstanding. I think a good indication of that is how infrequently you actually saw me over here. I came over here for the major milestones right after docking, and then EVA-3 I was responsible for, and then now here for the MPLM ops. So it's been great, and because there hasn't been any problems or minimal problems, that's why I haven't been over here to have to give you the story. So it has been just a great experience. I'll go over some of the major milestones or objectives that we accomplished throughout the flight. One of our primary objectives was to transfer Thomas Ryder over and get back up to a 3-person crew. We talked about the critical transfers, his seat liner and his pressure suit, and that was all done early on in the flight. But in addition to that, he's going to require clothing and food, and so we successfully transferred all those items. So he's definitely staying on orbit. The other big ticket item that we were looking for was EVA-2, and as I said earlier in the flight, that it was a roaring success. We successfully transferred our spare pump module. The repairs to the trailing umbilical system and the reel assembly were successful, and since then we've done a full-up checkout of every wire that goes to the MT, the mobile transporter. That's the power, the data, the commanding, and video. And we've now we've done 2 translations. The first translation was performed with the single string, and that translation took an hour and 50 minutes. And after we successfully tested, got the second string up and running, it took us an hour and 15 minutes to transfer back. So there is a substantial time savings if you consider that. And then when we start going down the whole length of the truss, it's going to make a big difference. So that's a huge milestone. With regards to transfers, they went really, really well. We had pre-flight had planned on and scheduled 128 hours, and it turned out that it only took on the order of 93 hours. And folks are wondering how that happened and what we can attribute that to. Obviously, we're going to have some debriefs with the crew after the mission, but what I'm thinking is that the guys on station, Jeff Williams and Pavel Vinogradov, they did a great job with pre-pack, and that just makes transferring cargo to the MPLM so much more efficient when they have that stage in a clean setup, so that it makes it easy for anybody to literally grab a bag and do the transfers. And then we had a full-time load master with Thomas Ryder. He received all the training, and because he was an augmentation crew, we had him all the way up until flight. So he received training all the way up until they left for KSC for the launch, and that made a huge difference when the EVAs were going on, and Stephanie Wilson who was our other load master, was doing robotics ops. Thomas was able to complete and do transfer ops, where in the past we haven't done as much transfer during the EVAs. So that was a big difference on this flight. Some of the more significant items that we transferred, and I've talked about this in my pre-flight briefing, but I'll go over it pretty quick. Now we have redundancy in our air conditioners on the station in the lab. We have the new oxygen generator system, which we won't activate until later on, but we still have the hardware on board. This particular flight, we've transferred more payload cargo than any other shuttle flight with the microgravity science glove box. We replaced the window on that guy. We have the new European modular cultivation system payload that Thomas Wright will be working with during his stage. The new freezer, the Melfi, we transfer that over. And then there was just a tremendous amount of supplemental hardware that went with all these items, plus other payload activities that will be taking place. We did a printer swap. We took the Shuttle's printer and replaced one of the ones we have on station. We transferred, or will be transferred by the time the hatch closed, 6 laptop computers, which we use daily on the station. We scavenged lights from the NPLM before we close it out. We always are looking to use, we can always use spare lights. We replaced some hardware on the cycle ergometer. And with the additional time that we bought back with the efficient transfers, the crew was able to even assemble it and check it out, which we really didn't plan on doing until after undocking. And it's been tested and it's good to go. So all in all, it was just a great mission from a station perspective. And I have to say that it's in large part due to everybody who's been involved in it, putting this together, from the people at KSC who put the vehicle together and integrated the hardware, the payloads, the teams here and that did all the planning, helped Tony and I plan this mission, and then execute it, to the crew on orbit. They did a great job. We worked them. We got our money's worth out of it, that's for sure. And because of all that, this was just a roaring success for the station team, and we're ready to proceed with assembly ops and moving on and complete the president's vision and getting through this program and then heading on to grander places as like Moon and Mars and hopefully beyond. That's all I have. Thank you.
Let's start with questions down here in the front, please.
Seth Bornstein, Associated Press. For Tony, how about explaining what's going on with the APUs and why you aren't concerned with the leak in, I think, APU-1, is it? APU-1
yes, sir.
tank.
APU-1. Well, right now, and you probably know the background of this, but APU-1's fuel tank decay about 3 times more than what we expected. And the folks been working this for the past 2 days. It could either be a GN2, the pressurant in that tank, or it could be the hydrazine in the tank. And they're still trying to determine, looking at all the environmental temps and what kind of leak or what kind of hydrazine leak rate it would be if it was actually hydrazine and such. So there's still a lot of work being done on that when I left. And they're also looking at the different options of what to do after we get undocked and such. And they're going to bring that to the MMT this afternoon, and Mr. Shannon, when he has his little MMT brief, I think it's 4 o'clock, yeah, he'll be bringing all the data and the direction we're going and all that. And on APU-3, we had a couple of there's 2 the nominal thermostats that we use are failed, so to speak, and the heaters are working on their over temp thermostats, which is really no problem. And they're working exactly in their temp ranges, and nobody anticipates any more problems with those.
Okay. Irene Klaus with Reuters for Rick. Do you have some updated numbers on the transfers, mass or pounds or items?
Okay, I do. Now they're still crunching them, so they may change a little bit when we're all said and done. But we transferred into the MPLM, from the MPLM on the station over 7,000 pounds. In pre-launch, we were targeting right around 7,400. So we've accomplished that. And on the return, we actually are bringing back about 300 pounds more than what we originally planned, and so we're right around 4,600 pounds on the return. That's not uncommon. We usually find other things that we want to bring home. For the mid-deck, we're pretty much, those numbers obviously are still in work because the crew's still doing some transfers, but we're right on target for where we were at this point. The numbers, like I said, are still in work, so I don't want to give you any numbers just yet because I know they're going to change because they haven't completed them. But it looks like we're right on target, both up and down.
What about water bags? And can you just give a ballpark or whatever your pre-flight estimate was for the mid-deck transfer? Thanks.
Let's see, Tony, did we get all 15?
We got all 15 bags. Was what our plan was when we built 15 and transfer them over to ISS.
And with regards to the mid-deck transfer, we're targeting right at 1,800 up and the same on return. and it looks very close that we're right in this ballpark.
Frank Moraine with Aviation Week for Rick. Could you explain a little bit more about the different translation speeds with the 2-string versus 1-string? And a separate question, the execute package mentions that this may be the most intense robotic mission so far. Is that so? And could you characterize how it compares to missions to come?
Sure, I'll give it a shot. With regards to the translation, a lot of the, excuse me, the overhead is on both the startup and the shutdown. The commanding that the team has to do, which I ought to take a moment to give kudos to the, we have a remote mixer up in Canada, and they actually did all the commanding from Canada. This is the first time they supported a docked mission, so it was a great job by those folks. A lot of that overhead is on both ends, and the actual drive time was a little bit less also with dual string. And I apologize, but I don't have the details on inches per hour or minute, however long it takes, but we can get that for you. And with regards to complexity of the robotics ops, it really was, you know, the whole having to walk the arm off for the inspections made it challenging. From the shuttle side, the OBSS activities, you know, those are new. I look at the past missions that I've worked, and it seems like they're all pretty complex. My last mission, we actually ended up replacing the failed joint on the station arm. So, you know, in my mind, that was pretty complex as well. But the team, the robotics folks, they just do a great job with all the pre-flight analysis and real-time changes. You know, the stuff they had to do for these inspections it's an enormous amount of work to build these trajectories, and I don't think people have a good sense for really what it takes, because you gotta go to the right spots, but you can't run into anything. And when you're talking an arm that has multiple joints that can be going in any direction when you're trying to drive, you know, it seems simple that you're moving the end effector from point A to point B, but the question is, what are the other 3 or 4 joints between the shoulder and the end effector doing at that time? And that's what makes it a challenge. So I would say yes, with the added late inspections and those operations, it was very complex, and as you can imagine, they're only going to get more complex when we're moving outboard and putting trusses, more truss on, and then putting the solar arrays on the outboard, moving the P6 from where it is on Z1 outboard. The missions from a robotics perspective are just going to get more and more challenging, but like I said, the teams are doing an outstanding job, so I have no concerns other than normal lead flight director worry about everything.
Todd Halverson of Florida Today with a couple of different ones. Tony, could you talk about the statistical probability of a shuttle taking an MMOD hit and what your capability is to redock the orbiter if you have to?
Okay, I'm not a statistics expert at any means, but the numbers that, you know, all the statistics in the MMOD has to do with your exposure time. So as we're docked, you know, we're limited to what kind of MMOD protection attitudes we can go to, and basically flying the -XTV attitude, which we do, is the most benign as far as the MMOD. Based on those attitudes, we have experts that run, you know, there's little pieces of stuff in the sky that they've gotten a good database based on when LDEF was up many years ago, that payload, and also, you know, we've been hit by little pieces of stuff on some various shuttle flights, but so they use all that data in their models to come up with a probability risk assessment as far as MMOD. And what the numbers that they brought forward prior to the flight and at the flight readiness review was if we didn't do a late inspection, the probability of MMOD damage that would be big enough to be of a concern to the orbiter was like 1 in 221. And with the late inspection, we mitigate that concern, and it goes up to 1 in 282. And the big thing is that now you're inspecting, you know, 3 days before you deorbit. So like I said, now your exposure time gets reduced, so your probabilities get better and better. Let's see, what was the other question? Redock, we have re-rendezvous capability. We have the propellant to do that, and as you know, all our systems are healthy. So what we're doing, like I discussed before, we're setting up a plan to provide the re-rendezvous capability just in case we need it. And of course, we're very optimistic, and by prior to crew sleep tomorrow, we should have the vehicle cleared, and we can go ahead and use one of those rendezvous burns, steep stitch for the entry G, can hope maybe use that for an orbit adjust versus a rendezvous burn.
Guy Gugliotta from the Washington Post for Rick. You said a little while ago that you had more payload cargo than any other shuttle flight. Is that by an order of magnitude, and does that include the MPLM plus equipment, or how does that break down?
I don't have exact numbers, but I think a lot of it is in large due to the freezer, the Melfi rack, the EMCS, the new European payload, and then all of the supplementary hardware that's going to go with that. And we can get you more numbers, but I think that is what it mainly due to is the additional payloads that are coming up in the freezer, and then all the hardware that goes with it.
Thank you, Red. Tarek Mack with Space.com and Space News. I have one for each of you, if you please. For Tony, I guess regarding the APU teams, what they're looking at. I'm just curious if these thermostat issues and the potential leak, if that's something that you've seen before on past flights, and is the current thinking that it's pretty much not a major impact for your landing plans. And then also for Rick, I'm just kind of curious about how, with the closeout of the MPLM and 100% transfer, how the station is pretty much prepared for the assembly and for its science future.
Okay. I'll go first since you asked me first. As far as heaters, we haven't seen it specifically on the APU heaters that have failures now, but there have been heaters on other systems that you lose the primary thermostat and it just operates on overtemp. So that in itself is not a new failure. As far as the fuel tanks on the APUs, there is a decay just based on thermal in that. So the APU-3 is, I hate to use out of family, but it's a little bit different than the other two. I'm sorry, APU-1. APU-1 is a little bit out of family than the other two. So again, folks are still trying to understand that, and it could be, like I said, either N2 or hydrazine. So they're looking at the N2, which would be no impact, and of course they're looking at the hydrazine and what the leak rate is, what the heaters. There's some BTUs that get put in the aft compartment that may mask what the impacts of the hydrazine are. So they're still looking at those different options, and the M&T briefing this afternoon, John will have much more details than I have.
And for the second question, after 121 successful completion here, we can continue with assembly option. If we weren't successful, we weren't going to be able to do that. And the big part of that is the recovering redundancy on our mobile transporter. Very next flight, they're going to be doing a lot of translations and working from that mobile transporter. And without redundancy, we're basically hamstrung, and we can't translate and do the ops that we need to. So because of that, we can continue with this sequence. And then with regards to our ability to perform science, having Thomas on board, 50% increase in utilization. So and the new payloads, I wouldn't say it's going to increase payload utilization by 50%, but it's going to be a substantial number, just having the extra body there to do the ops. So this is a great mission for us, and able to continue with the assembly sequence and improve our utilization for sure.
Seth Bourne, San Associated Press. One more for each of you. Tony, just because it's been so long and it's so early, if it is hydrazine, what are the worries? I mean, I assume there's an environmental worry. Can you just go through what could be the problems you'd be adjusting? And for Rick, any examples of some of the extra return 300 pounds of what's coming down that wasn't expected?
Let's see, and I'll just do generically hydrazine. The concern is for any type of hydrazine that once you get into the atmosphere and you have oxygen in the right conditions to go ahead and start a fire in that then. So that, that of course is a concern, and again, the folks are still looking at that and trying to determine based on all the leak rates and that if that is a concern, and they'll have plans developed that says, hey, if it does happen, here's what we'll do. And we've had on STS-9, I think I remember, we did have a hydrazine fire in the aft compartment, but we safely shut everything down, and there was no problem or no concern or danger to the crew.
And I apologize, but I really don't have any details. I mean, not 300 pounds worth of details, that's for sure. I know we have some additional gloves, Orlon gloves, that we didn't require on orbit, and we accumulated some broken equipment, some of the old Cevis vibration isolation system hardware, but I really don't have any other details, but we can get that for you, for sure.
Todd Halverson of Florida today again for Tony. Refresh my memory, is the shuttle robot arm and the OBSS actually in the deployed position when you undock, and what are the loads issues with that? And secondly, I'm wondering if you can discuss undocking with without the verniers, and whether that makes the piloting task any more difficult.
Let's see, the first one is what we do. It's the I know we have, I don't know if we have a picture of it, but basically we put the OBSS in the handoff position, it's called, the same one that we would use if we were going to grapple it with the SSRMS. So loads-wise and such, we went through and we did analysis on that, and it's a certified capability. As far as undocking on primaries versus verniers, the crew's trained. There it is right there. The video can show you what position we'll be undocking in. And as far as the difficulties with doing an undock on primaries, basically you just don't have as fine control as you would on verniers, but the crew's trained to do that. They understand what they're looking for, so there's no concerns at all on that. And what our plan would be is once we get done with SEP 2, we'll go ahead and go back to the 5-pack vernier control that we had prior to docking.
Okay, and I understand there's a question at Kennedy Space Center, so we'll go to there next.
This is Jay Barbary with NBC News. A couple of days ago, you had a rather dire prediction on weather here for landing. It's beginning to dry out after this wave has gone across the state, and I'm told this morning that it's going to be dry here Monday. And could you give us a look at what you're looking at now, Tony?
Well, to be honest with you, just like anything, we have predictions, and I understand the weather's going to be good, but you won't really know until Monday prior to Palo Bay door closing. But everyone has a good feeling, but again, you won't really know until Monday.
Thank you.
Okay, that was the last question at the Kennedy Space Center. Are there any follow-ups here, back here in the back?
Thank you. Just Tarek Malik with Space.com and Space News. And for Tony, just about the crew as they prepare for undocking tomorrow, kind of once they get the NP1 back in the bay, what are the other activities that they're going to be going through to make sure, I guess, that they're rested and prepared to leave their companions on the station part?
Well, it's a standard like I had talked about. We'll get the MPLM in there. We'll perform the port late inspection. We'll get the OBSS in the handoff position. Let's see, I think tomorrow morning's the farewell ceremonies. And I think it was yesterday evening they got together and had dinner over in the SM. So, they're still working hard and still talking to each other. And like I talked about before, we have the scheduling constraints that we make sure we don't get them all tired. And I was lucky enough, Steve Lindsay gave me a call when I was on console, and he said everybody's doing great, and they're pressing on, they're ready to do a late inspection. So everybody's doing good. The standard, just make sure we, like Steve said, and I think in one of his interviews, make sure we don't get complacent. We still have some critical activities ahead of us, and we really shouldn't relax until, we get both the main and the nose gear on the runway.
Okay, are there any others? Todd?
Todd Halverson of Florida today again. Are you doing anything in particular, since you're using the primary jets, to make sure you don't put any exhaust on the solar arrays?
No, the primary jet configuration protects for that. You know, the whole back out profile, you know, when you back out, you use the primary jets to get your RDOT and do your get your separation delta V. And like I said, the vernier jets are more of the fine attitude control after you put the impulses in to start backing out and all that. So you follow the same procedure that we have with vernier jets, just that you use primary jets for attitude control versus verniers.
Okay, I think we'll wrap it up here so we can send you right back to Mission Control for the live operations of stowing the multipurpose logistics module. Come back here for our post-mission management team briefing that's scheduled for 4 p.m. Central Time. Until then, thank you.
The activity being conducted by Lisa Nowak and Stephanie Wilson, 2 of Discovery's mission specialists, working at the robotics workstation in the International Space Station's Destiny Laboratory module. Today's unberthing from the Unity module occurred at 8:25 a.m. Central Time. So far, the procedure has gone nominally, with the crew able to continue using the course rates on the space station's robotic arm. Attitude determination and checkout officers in the International Space Station Flight Control Room, working carefully with the guidance navigation control officer here in the Shuttle Flight Control Room, as the 2 watch over the momentum management system of the International Space Station that is being used to maintain the combined stack's attitude or orientation relative to the Earth.
Scan 2 for EMU reconfig.
Please go ahead for EMU reconfig.
Hi, Julie. We are on page 2-15, and reconfiguring EMU 3009 for me as a contingency suit. And we want to make sure, check with you if you want us to move my COMCAP from 3006 to 3009. It's not in the checklist, but we think that would make sense.
Please recopy the question. We're checking.
As Nowak and Wilson will continue to work with Leonardo's stowage in the cargo bay of Discovery, spacewalker Pierce Sellers working in the Quest airlock module with pilot Mark Kelly on the reconfiguration of spacesuits that have been on the International Space Station. They'll be returned back to Earth on Discovery and being prepared for use by
Spacecraft 2. Do we have a go for step 3.1 and nitrogen transfer terminal?
Space Station robotic arm operators Stephanie Wilson and Lisa Nowak are in the process of moving Leonardo now to the low hover configuration, where it'll be holding just above Discovery's payload bay. This is Mission Control Houston. The delivery of the Leonardo cargo module back into Discovery's bay is in the process of being completed. Right now, the Space Station's robotic arm operators, Lisa Nowak and Stephanie Wilson, have returned it into a hover position over Discovery's payload bay. We're looking at a split view from the cameras on either side of Discovery's payload bay right now. And in the center, the pointed-looking object that is being lowered down into Discovery's payload bay is actually both sides of the Leonardo module, as they're compressed by this side-by-side view.
At Station Discovery, we have the MPLM fully latched with 4 good latches, and we're complete through step 9. You got the top of 10, and then we'll pick it up.
This is Mission Control Houston, receiving live television of the space station's robotic arm as Lisa Nowak and Stephanie Wilson in the Destiny Laboratory module ungrapple the Leonardo multi-purpose logistics module. It's now securely fastened in Discovery's payload bay once again with 14,000 pounds of return equipment coming home to Earth after a successful trip to the International Space Station to deliver more than 5,000 pounds of supplies and equipment for the Expedition 13 and subsequent crews to use. This is a good look at Commander Steve Lindsay and Flight Engineer Jeff Williams, along with the new Expedition 13 crew member Tomas Ryder, as they work on reconfiguring the interface umbilical assembly for the space station's mobile transporter. This is the failed IUA that was brought back inside the International Space Station following the second spacewalk. This is Mission Control Houston, receiving live television of the space station's robotic arm as Lisa Nowak and Stephanie Wilson in the Destiny Laboratory module ungrapple the Leonardo multi-purpose logistics module. It's now securely fastened in Discovery's payload bay once again with 14,000 pounds of return equipment coming home to Earth after a successful trip to the International Space Station to deliver more than 5,000 pounds of supplies and equipment for the Expedition 13 and subsequent crews to use. The space station's robotic arm continuing to be maneuvered by Stephanie Wilson and Lisa Nowak. They are wrapping it essentially around the Destiny Laboratory module to the truss structure where they will grapple a mobile base system power and data grapple fixture that is on the mobile transporter. Again, that mobile transporter repaired on spacewalk number 2 when Pierce Sellers and Mike Fossum replaced a cut trailing umbilical system cable. And with that replacement reel in place, the mobile transporter and its mobile base system for the robotic arm now capable of moving up and down the station's truss structure in support of assembly and maintenance operations. Robotics officers Lisa Nowak and Stephanie Wilson now going in for the grapple on the mobile base system of the International Space Station's mobile transporter attached to the truss structure of the space station.
Hello, ladies. Hail to the Robo chicks.
This is Mission Control Houston, the space station's robotic arm once again in motion. Again, this is going to be a move using the mobile base system as the base for the robotic arm. It'll move the previous base, which was attached to the grapple fixture on the Destiny Laboratory module, over into position where one of the cameras on the starboard truss structure can take a look at the snares inside that latching end effector to make sure that they're properly in their guide tracks.
Houston Station on 2, we show ourselves complete with the SSRMS ops for the day. Do you concur?
Station Houston for robotics. We concur, and Stephanie, Lisa, we believe this completes your SSRMS big arm operations for this flight on behalf of the entire Robo team here on the ground, and that includes those that were supporting and operating from the Canadian Space Agency headquarters in Montreal. We'd like to congratulate you on a job well done. To quote our Robo lead here, Orbit 2, Scott Freeman, we're very proud. Well done, guys.
Well, thank you very much, and we'd also like to extend our thanks to all the folks that supported us both during the mission and during our training. There was a lot of people that helped to support us, and we're just very thankful for all their hard work and their great instruction. Thanks again.
We copy, Stephanie. Thanks for those words. We'll pass them along.
This is a look at the end of the orbiter boom sensor system where laser dynamic range imaging system is going to be used to scan the leading edge of the left or port wing of the Space Shuttle Discovery in a in a late inspection activity, taking a look at exactly how well the leading edge of the wing is looking after being docked to Discovery for this period of time.
Discovery, looking at the image that we're getting down on the ground now, we like what we see at this time, so it appears to be a good image to us.
We concur with that.
Thanks, Steve. Nice job.
This is Mission Control Houston, the crew on the Space Shuttle Discovery in the process of scanning the leading edge of the left or port wing using the 50-foot long orbiter boom sensor system grappled to the end of the 50-foot long Space Shuttle's robotic arm. This part of the additional inspections to look at the condition of the leading edge of that wing following the docked operations with the International Space Station. Commander Lindsay being given the opportunity to decide whether or not to proceed and try and accomplish these scans, and deciding it was the right thing to do. Spacecraft Communicator Lee Archambault and Orbit 2 Flight Director Norm Knight assured the commander that the shuttle program would be okay if he decided it was in the best interest of the crew not to complete the scans, but he elected to go ahead. So those scans now in progress. These scans a mixture of pre-programmed and manual positioning of the robotic arm with its orbiter boom sensor system.
Copy with recorders on, point 58. Thanks for the tag up. Okay, Steve, with that, we see ourselves about 25 minutes to your official sleep time. We know it was a full day today, and certainly exacerbated by some of the issues that we had with the big arm for a while there, put us a little bit behind, but we certainly applaud your efforts to get us back caught up, and we got everything accomplished we wanted to today, so congrats to you and your crew for going above and beyond. And so at this time, we're going to go ahead and sign off. The ISS control room does have a couple of closing words for you. Apparently, this is going to be their last time to talk to you, so they'd like to make some closing comments to you and your crew. So with that, Shuttle control room is going to sign off.
Okay, Boo, thanks. Tough day, but we got through it, so hopefully we're caught up on the timeline for tomorrow.
We concur.
Discovery Houston on air to ground 2.
So go ahead, Julie.
Hey, Steve, this is the last operational shift for the ISS Orbit 2 flight control team. I'd like to say goodbye. Is this the right loop to do that?
Yeah.
Well, what can we say? This has been a tremendous ride, and it was a true honor to be here and the privilege to follow this mission. So on behalf of everybody here on the ground, Steve and the crew of Expedition 13, congratulations on an absolutely tremendous job accomplished. We'd like to bid farewell to Thomas, Pavel, and Jeff on the continuation of Expedition 13, and for you guys, safe landing. We'll be seeing you on the ground. Good night.
Hey, thank you very much, Julie. It's been a pleasure working with you guys, all the shifts. I know Rick's probably sitting there right now, and I really appreciate all the work Rick put into this over the last few years. If he was like me, he was sweating bullets through the second EVA especially, and but we got it done, and I'd like to commend the entire ISS control team for just exceptional execution. If you guys hadn't put together the plan you did, we wouldn't have got all this done. There's no way. So we appreciate and enjoy working with you, and as shuttle crew, we look forward to seeing you in hopefully just a handful of days.
And we will. Indeed, Rick was supposed to say farewell, but decided to let me do that, I guess. Take care.
Well, good afternoon, everybody. It is still afternoon Central Time, and we're here with our post-mission management team meeting. It went kind of long today, and John Shannon, who is the deputy manager of the Space Shuttle program, is here to tell you all about it. He's also chair of the mission management team meeting, and I'll turn it over to him, and he'll give you his side of the story today, and then we'll throw it open for questions. John.
The why I'm late story, okay. Thank you for hanging with us. I haven't seen you in about 3 days, and they've really been 3 great days. I wanted to say just a couple words about the EVA number 3 that we did, because it was really a shuttle, a primary shuttle-based activities. And we walked into this mission, kind of the 2 test flights, STS-114 and STS-121, with several unanswerable questions, and we would have endless debate in the hallways and discussions, and they all keyed around inspection and repair and thermal damage, and the way to answer those questions, the only way to answer those questions was through doing a flight test. And I was so excited about getting EVA 3 done. One of the unanswerable questions we had was on the RCC repair. And would NOACs stick effectively to RCC? It had in the human thermal vac chambers that we have here in the 1G environment. But you can never put 0G and vacuum all together in one spot except up in space. And now we have 5 samples that the crew put together for us. And 2 of those we'll bring back here to Johnson Space Center. We'll put in our ArcJet facility and run them through a very characteristic entry that they would see if they were actually a repair on the wing leading edge. And we'll answer those questions for once and get that work done. The other kind of unanswerable question was on the IR camera that you saw. I don't know if it's really clear why we wanted that data so much, but if you have a small crack on your reinforced carbon, if you had a piece of ice or a piece of foam or something that created a small crack that you would see on your wing leading edge indicator, you'd go look at that crack and you would probably end up saying, you know, you're okay to re-enter. But the RCC, of course, is a composite. It's laid up weaves of composite material. And the concern you would have is, okay, I have a little crack on the surface that I can see, but what is under that crack? Did I delaminate between the sheets of composite? That would be a very serious case if you did, because you would end up under entry heating flaking off pieces of that composite, and it could lead to a much larger problem than you would see on the surface. So that IR camera, an infrared camera, gives you that capability. You let the sun warm up that panel, and then you can go look at it with the camera. And it's a great way of telling if there is something larger than what you can see just on the surface. We have one of the photos here. Why don't we go to the first one on the RCC? You can see the kind of the before and after of what the crew did, what they saw, and then the subsurface looks much worse than what you actually see on the surface of the RCC panel. And the guys have models that they can tell how deep damage would go through the RCC composite, and then what that could potentially mean to you for entry. Why don't we go to the next chart? This was just a shot, and this isn't really representative of anything other than you can see that the RCC heats up during a pass through the sun, and then you could see how it would cool down during when you went into darkness. And the way that it would diffuse that heat out can tell you a lot about the properties of the RCC. And so if you had some questions about some area, essentially we have got an equivalent of a CAT scan or an X-ray for RCC by having this capability. And it tells you really how the heating is going to react with that composite. So I was just extremely thrilled to get that data on that EVA. You know, the other one, it was back on EVA 1, was the repair on the boom. There were endless debates and endless modeling, and we set up an air-bearing floor and tried to understand what the boom, how it would react. And a lot of folks thought, well, you can't use it for repair, or you're going to need some special stabilization, and we had started some looks at that. But as you saw in EVA 1, we got some great data, and we'll put that back in our models, and it looks like it will be a very good repair capability for us. The last one that we're actually was just underway a little while ago, and we'll do more of tomorrow, was MMOD. The micrometeoroid orbital debris. When we went through all of the risks to the shuttle, it was number 2 on the list. And historically, we had not done much to mitigate that risk. It was just kind of part of the space environment, and you lived with it. On STS-114, what we did is we turned the entire docked stack around, so the space station was essentially a big shield for the shuttle. But the periods of free flight, you would change your attitude, but that was no real positive indication that you were okay. So we decided on STS-121 that we would go ahead and spend the crew time and take the boom out and go do a scan and see how well we could determine if there was any MMOD damage. And of course, doing all the scans on flight day 2 gives you a very good baseline. So you can do it this late in the mission and feel really confident about your results that if you saw a difference, it would be something you really had to go look at. So I feel, as part of the program, very encouraged that we're taking risks that we used to think you just had to kind of live with, and are doing positive things to get us in a better configuration. Another thing we're going to get kind of free on this one is with the gap filler that is out on the port wing, and also potentially the one that's in front of the ET door. We have flown back with over 1,000 gap fillers protruding from different orbiters at different times. But what you don't know is, did that gap filler work its way out when you did slap down on the runway? How far out was it during the on-orbit time period? How far out was it, at some other time? We didn't have the initial, here's what you started entry with, and then be able to look at what the boundary layer would do. Well, we have that on this flight. We know exactly what the protuberance height is, and we have some thermocouples downstream of them that can tell you when you get your boundary layer transition, when we see a little bit higher heating in that area relative to the same thermocouple on the other side. We also are working very hard, and I'll talk about it a little bit more when I talk about the MMT, to try and get some aircraft up that could maybe look at the underside of the vehicle and tell us thermally through infrared imaging if we have tripped a boundary layer or not. We had already had that planned for this flight, but we're trying to get them at a little bit higher Mach number. That's going to be huge for us, because the big endless debate we're in on gap fillers and boundary layer transition is, when does it trip? If it trips at Mach 25, that's a very different thermal environment, much more severe than Mach 18. And our history has shown that Mach 19 was the highest we've ever tripped, but we really don't know what caused that trip. Could we be in a case that's actually worse? So we're going to get that, I think, that resolved on this flight as well. Back to today, it was great to see the MPLM back in the bay. The problems that we had with the space station arm put us about an hour down on the timeline, and the crew, after some discussion with the ground, decided they would like to go ahead and get the port wing leading edge scan for MMOD done. I think you heard all that. And I just talked to the flight control team, and they got about 50% of that data on the ground. They get the rest of it on the ground in the morning after the crew wakes up. So today was a great day. We have done a lot on this flight to answer some of those unanswerable questions, the things we could not answer on the ground, and it's going to make us a safer program for the outer flights. The MMT did just wrap up. It was a long MMT. The big news out of that, I told the team, and we received the go from everyone for undocking tomorrow. And I know the ISS team did the same thing, and their go for undocking as well. So we see no issues keeping us from undocking. We did talk 3 issues. One of them was the entry imagery plan, and Leroy King down in Kennedy Space Center had been working with the different assets we have to try and get some imagery of the vehicle. And we're going to use our WB-57 aircraft out of the Gulf of Mexico. And there's also a Halo aircraft, which is a Gulfstream that's run by Aeronet, and they can do some infrared tracking for us as well. We have some other things in work along those lines to try and get some data there, and that's all for the boundary layer transition discussion I just talked about. We also reviewed the MADS data. If you remember, MADS is the recorder. It's multiple ancillary data system, I think is what it's called, it stands for. That's the box that after STS-107 we found laying on the hill, and it gave us the great insight into what all the different temperature and pressure measurements were going on inside the wing. The CABE recommended to us that we be able to downlink the MADS on orbit, and this is the first flight that we had that cable installed to be able to do that, and we downlinked all the MADS data. We ran through it at the MMT. There was 100 different parameters the team looked at. They found one that was out of limits. We'll go replace that instrumentation. They found one that showed a little different pressure trace than they expected on forward bulkhead between the forward RCS system, and the team is looking at that, but it was not really a big issue. It may just be an instrumentation bias. But it's good to have that capability. If you think back to Columbia, we did not have a way to get down any of the pressures or temperatures in the wing during ascent, and that may have been an additional clue we could have used. So now we have that capability. And of course, the big one that I'm going to spend a little bit of time walking you through was the APU-1 issue, which was the fuel tank pressure decrease that we've been kind of watching. And I'm going to tell you everything I know and just kind of walk you through it, and I'll tell you where I think we're heading on it. Why don't we get the first graphic up here? This is the APU fuel system here, and I'm gonna just kind of walk you through from left to right. The circle on the left is the fuel tank that we're talking about. We have 3 APUs. Each of them has a separate fuel tank. And inside the fuel tank is the fuel that runs the APU, and it is hydrazine. It's N2H4. And to push that hydrazine down to the APU, we pressurize it with gaseous nitrogen. So there's nitrogen on one side, there's a bladder separating the nitrogen from the hydrazine, and then there's the hydrazine. And you can see on the far left of the drawing, there's a service line that we use to fill up the nitrogen system, and then there's also a line coming from the same service panel on the side of the orbiter that we fill up the hydrazine system for it. Now, after moving from the tank to the right, you'll see a little square that's a fuel filter, and then there's a box with several triangles in it, and that's fuel isolation valves. And basically what that does is that cuts off any flow from the tank down the fuel lines to the APU itself. And we have really good confirmation from the data that we have that there is no leakage downstream of those fuel isolation valves. So there's about an 8-foot run of line from the isolation valves to where the APU actually is. And it looks like everything downstream of the fuel isolation valves is really tight, and there's no leakage there. Okay, now if we got that, let me go to the next chart here. And we can, when we do questions, we can come back to all these. This is kind of how they're mounted on the side wall. If you were looking through the main engine bells and you looked kind of at the 9 o'clock position, you would see APU-1's fuel tank and then APU number 2's fuel tank right below it. And you can see the lines kind of coming out of the top of APU-1 fuel tank. That line coming out the top and snaking down the side of that panel, that's how you feed the nitrogen in to pressurize the system. Then there's a line coming out of the bottom of the tank that goes to that same service panel. That's how you would fill it up with hydrazine. It's the same thing for APU-2. Let's go to the next chart. Okay, here's what the team has been tracking, and pretty much the far left of the graph is liftoff, was on launch day. You can see the top trace that's kind of stair-stepping down. That's the pressure for APU number 1's fuel tank, and we have 2 different pressure measurements there, and they're tracking about the same. And for comparison, you can see APU-2 and APU-3 right below it. Now, APU-2 and 3, we don't think have any kind of a pressure decay that's off normal. They're just cooling down, and as they cool down, the pressure decreases very slowly. You can see that APU number 1, though, went from the 254 pounds per square inch down to 230 pounds per square inch, which was what we did not expect. Now, if we can, let's see what we got here next. Let's go to the next one. This is kind of where they're all located. You can see where the fuel tank number 1 is, and of course 2 is right below it. And it's got that run to where APU number 1 is and APU number 3 is. APU number 2 is kind of between those 2. You can also see the circle on the far right of the bulkhead, and that's where APU number 3's fuel tank is. The thing probably to notice here is that while APU-1 and APU-2 and APU-3 all get very hot during re-entry, they're a long way away from the fuel tank, and we'll talk more about kind of what that means here in a minute. So what's going on? That's kind of the question right now. Is you have this leak, and okay. Yeah, I'm not sure I want to go back if we didn't get them. If we didn't get it, yeah. The question is okay, what's leaking? There is some anecdotal evidence, or maybe a little better than anecdotal, that it's nitrogen and there's no issue at all if it's nitrogen. Because the leak rate is so slow, you're certainly going to have plenty of pressure when we re-enter in 3 days that we could start the APU and run it and there would be no issue at all. If you had a nitrogen leak, the hole size would be 0.0003 inches, and which is pretty small. And if it was fuel, it'd be twice that. It'd be 0.0006 inches for fuel. There's a lot of bins, a lot of connections on the nitrogen side. Pre-flight, we had one of the poppets down on the service panel. It was sticky, and they had to reseat it in order to get it to stay. They did put a flight cap over it, which makes you think maybe that poppet wouldn't be leaking, but that has a little vent hole in it as well. So there are a lot of folks that think it's GN2, and my thoughts on that are it's a coin flip. You don't know if it's GN2, you don't know if it's hydrazine, and what I've asked the team to do is let's just treat this like a hydrazine leak and go think about what we should do to make sure that we're in as safe a possible config, assuming it is hydrazine. Again, if it's nitrogen, we don't need to do any work. There is absolutely no issue at all, and we'll just, when we turn the vehicle around, find out where it's leaking and fix that. Okay, now if it's hydrazine, the question here is first off, are you safe right now? And the leak rate, we had to try and characterize that pressure decrease, is about 18 cc's per hour, or about 6 drops per hour, and which is not much hydrazine, especially when you're in a 4,000 cubic foot aft compartment. What the analysts have told us, and we're running tests at White Sands Test Facility, and we're getting independent confirmation with the NESC, the NASA Engineering and Safety Center, is that if we had that small of a leak and it was hydrazine, what would happen to it? Because hydrazine in a vacuum can do one of two things. It either goes directly to a solid, freezes to a solid, or it goes to vapor. And at this pressure and at this small of a leak rate with heaters on those lines, they will provide enough heat, it looks like, to completely vaporize any of that hydrazine that would escape. So what you end up having is vapor that's at vacuum in the aft compartment that is vented out to space, so you really don't create any concentration whatsoever. And keep in mind, this is a very, very tiny leak, and it you essentially have no on-orbit concerns for flammability at all. We do close those vent doors, though, as we re-enter. When we hit the atmosphere, when we go to major mode 3 or 4 or the entry phase, those vent doors go closed. So then the next question was, if you had this same leak rate going to vapor for the time from the doors being closed down to when they're reopened at Mach 2.4, would that cause a problem? And the team looked at it, and we are about 100,000 times below the flammability limit for this leak rate size. And that is taking into account the fact that we do a helium purge just a little over Mach 5 before we open the doors. So it became very apparent very quickly that even if you assume this is hydrazine, at this very small leak rate, you did not have a flammability concern for entry. And the worst you could possibly have is if it is going to vapor, once you landed, you might have a few drips coming out of it that we would have to clean up once we got in the aft. We talked to the ground operations team at Kennedy Space Center, and they would typically go up and sniff for any hydrazine with the long poles they put up by the vent doors. If they saw any, they have procedures in place to vent, and then they would just depressurize that system and take all the head pressure off of it, and we assume it would stop leaking. Okay, so the team got really comfortable really quickly that if it's hydrazine, if it's going at this rate, that you're okay. The next question is, what if it gets worse? It looks like this leak or this decay that we have in the tank started during ascent. And if you refer to that graph chart, the system was sitting there for over 20 days on the pad tight, and we had no decay whatsoever. And then after launch, you started to see this very slow decay. Now, the team didn't really pick it up until about 2 days. There we go. There's a chart again. It was very, very tight, and then after launch, then we started this step down. And it was very hard to pull it out of the just normal thermal data until about 3 or 4 days ago. And the team looked at the data and said, you know, this looks a little bit different to us. Pulled a bunch of historical data on that APU, checked where the sun's shining to make sure they weren't getting fooled by anything, and then came to the team and said, we think we have something that this decay does not look normal to us. So the question is, you know, is it going to get worse? And that's what we spent a lot of time talking about today. Again, if it's GN2, if it's the nitrogen side, there's no issue at all. Even if it got worse, the worst thing that could happen to you is you would lose the head pressure on that tank, and you would underspeed the APU, and it wouldn't be available to you. But that's not a hazardous case at all. If the hydrazine got worse, well, then you got a concern that you're going to put some hydrazine into the aft compartment, and even though there's no hot spots or ignition points around that fuel tank, you don't really want to have hydrazine in there because it's a very caustic chemical, and it can cause damage to other things. And it's just not a situation you really want to be in. So what the team is thinking about now, we laid out 10 different things we could do, and we worked through them all in the MMT today. And they range from don't run it, go dump it. How long do you run it at FCS checkout? How long do you run it for entry? When do you start it? We went through just absolutely, I guarantee you, every permutation you could possibly think of for what to do with the APU. And the consensus of the team was that the best thing to do with this small of a leak rate that is not an issue is to go run it for flight control system checkout on Sunday morning. And what that'll do is it'll allow you to start it up, to take a look at it, to see how the fuel is flowing, to see what the pressure traces do, and you're putting it basically through what would be the normal start time. You bypass flight control system ports, which is a big boom, so it kind of shakes the system up nominally when you're doing flight control system checkout. Then we'll shut it down, and we'll go look at the pressure trace. And I fully expect to see that we won't have any change at all. And if that's true, I would expect that we would use it for normal entry. If we did see a change in the decay rate, if it got higher, even if it has a long way to go to get above flammability limits, but even if it changed, that would say it's not really a stable situation, and the operations team would go ahead and burn it off on orbit, get all the hydrazine out of that tank, and we'd be done with it, and we'd just re-enter on 2 APUs. 2 APUs is fine. It's certified. It's not as good as 3 APUs. You'll lose some things with hydraulic system number 1 not being active. The most important probably is that you don't hydraulically deploy your landing gear. You end up doing a pyro deploy. You basically blow pyros that releases the uplock latches to let the gear down. While that is perfectly certified and it is dually redundant, we have dual pyros, you'd rather do a hydraulic deploy just so you have 2 fault tolerance on that entire system. So the way I would wrap up on the APU is we can't tell right now if it's GN2 or if it's hydrazine. The team is treating it like it's hydrazine just because if it's GN2, we're done talking. It's a very straightforward, no issue at all. For the hydrazine, at the current leak rate, we really don't have any concerns with using it at all. We have concerns if it is going to change and start leaking more. We don't expect it to, since it went through ascent and didn't get any worse. The entry environment is much less. So we're okay where we are right now. We're okay if it stays the way it is right now. We're going to go do FCS checkout with this APU to make sure that it doesn't change. If it does change, then we'll burn it off on orbit. If it doesn't change, we'll probably use it just as we normally would for entry. And the team, we did not have to decide anything today other than we would like to use it for FCS checkout. So I left the team with 2 actions. They're going to go off and give me a recommendation for how long to burn it on FCS checkout. How long do they think is appropriate to really check out the system? And the second one was the start plan for reentry and when they would like to start it and how far it'll go down. The Kennedy Space Center team can certainly handle any kind of leakage that we would have on the ground, but there is some thought that, hey, we would like to get as much hydrazine burned off during entry as we can just so we don't have to worry about it if it turns out to be that kind of leak. There have been some comparisons to STS-9, which was a very serious situation, but it was a very different situation. While the area and the constituents were the same, the way the way it happened is very different. On STS-9, what's called an injector stem, or basically where the hydrazine goes into the APU, had a stress fracture in it, and it started spraying hydrazine directly on the absolute hottest part of the APU, and this was during the final time frame. And that hydrazine, while the liquid did not do anything, it created vapor around it in that very hot atmosphere, and then it auto-ignited, and we had a fire on STS-9. Now, why is that this different? Two main reasons. One is the leak rate is extremely small, but the position is totally different. The fuel tanks, the guys that designed the shuttle were really smart. Just like in your car, you put the gas tank in the back and the engine in the front, right? It's kind of the same way in the aft part of the orbiter, is the fuel tanks are on one area, and then you've got an 8-foot run to where the APUs are. And that's where your hot spots are. They're also above where the fuel tanks are. So if you had a leak that was dripping, it would not drip onto any kind of hot spots. If you had some kind of an ice buildup in there, it would not be able to get up to those hot spots on the APU, and that makes you feel pretty good about it. So the team's working through all those questions. The two major ones are, for FCS, check out how long do you want to run it to maybe reduce the amount of hydrazine that we would carry back to the landing site. The second one is when do you start it for reentry. I think that the preponderance of the evidence is headed towards we're going to use it just like we expected to pre-flight. I'm going to let the team have another night to go think about it and make sure they've thought about everything. We do have folks from across the agency involved. We've got White Sands Test Facility, who has a lot of experience with this involved. We got a report from Goddard Space Flight Center, who ran an independent analysis of the rate of vaporization of that hydrazine. We just have folks involved all over and weighing in on this discussion, and I feel very confident we're going to come to the right answer tomorrow. So that's what I got.
Okay, questions. We'll start with Seth.
Seth Bornstein, Associated Press. John, just to go through some of the numbers again, in terms of how much hydrazine is in the one tank, what's the leak rate you think you have right now, and at what point does that leak rate get to the point where you talk about if it gets worse? There must be a rate that you say that's when we're really nervous. So if you could tell us that nervous point, really nervous point, and where it is and how much hydrazine's in there.
Sure. Right now the prediction was that we would have about 13 pounds. If you could catch it in a bottle and leave it there, it would be 13 pounds of hydrazine, which is a little under 2 gallons. Again, we think that's going to vapor. Where would I get really nervous? Where I would get nervous doesn't have anything to do with how much hydrazine it would be if I saw a change in the decay rate, which said we would have an unstable situation. And I think any change in the decay rate that was perceptible to the ops team, I would say, hey, the better part of valor here is to go ahead and burn it off on orbit. So we'll look at it very carefully after FCS checkout, after we start it up and run it. And if we see anything that deviates from what we've seen, the performance we've seen so far on orbit, we would end up burning it off. But there's no specific, I can't say, well, if it increases a little bit, I'm okay with that. If it increases a lot, I'm not. If it increases any, we're going to think, this is not a real good situation.
Gina.
Gina Sinceri, ABC News. I'm interested in what you were talking about with the MAD system and what you're seeing from that data. You talked about an increase in pressure in the nose cap. Could you explain that a little bit more, please?
Yeah, there's a lot of, the problem with MADs is that you don't have redundant sensors. They're just instrumentation. And the team was looking at the delta pressure between the forward RCS cavity and the bulkhead that separates the forward RCS cavity and the crew cavity. And normally they see about half a PSI difference. And this time it stops at 1 PSI, so they really couldn't tell, but it followed kind of the same trace of 114, but it looked like it peaked out at about 1.2 PSI delta. The team is running all the stress analysis that if they think it's instrumentation, if it's not instrumentation, would you have broken or bent anything up in the forward? And the initial analysis came back and they said, no, it would not have. There would be no issues with the slap down rates when you touch down on the runway and you put the nose down. That's where you'd have stress in that bulkhead area. They characterized it at the MMT as a quick and dirty analysis, so I sent them off to go do Rev 2 of that analysis and come back and tell me what the answer is. But their initial one that was a very conservative assessment said it would be just fine. So I think it's the first time we've ever brought MADS data down on orbit. We're looking at single string or 1 point information, and we just have to kind of work through that. But the team's treating it very seriously. If it was real, they're going to go make sure that the stress analysis is appropriate, that we wouldn't have a problem.
Irene? Thanks. Irene Potts with Reuters. If there is a change in the leak rate, when would the burn-off occur? Yeah, I have a whole bunch, so I can put them all together. Or they're quick.
On APUs now.
Yeah.
Well, we'd leave that to the ops team to figure out the right time. If it was a significant change in leak rate, of course you would want to get on it as soon as you possibly could. And oh yeah, I would think that we're going to get a little bit of thermal soak back, not a lot, but a little bit of thermal soak back from running the APU, which will make it a little more difficult to pull out what the pressure actually is. But I think the team within hours of the FCS checkout will be able to tell if it changed.
Operating temperature of the APU? I know it's far away from where the leak.
It's about 500 degrees.
And, have there been any 2 APU landings besides the STS-9 that you described?
Actually, STS-9 did land on 3 APUs, but they had a fire afterwards. I do not believe, I will check for you, Irene. My memory says we have not landed on 2 APUs, but I believe we have had late starts of APUs on a flight where you would start it at either Mach 2.5 or Mach 1 because of other issues.
So you've never done the pyro landing gear deploy?
No, we have not. We fired the pyros once, but that was not on purpose. It was after landing. But, yeah.
And the last question is there anything else that you can do to rule out a hydrazine leak, or at this point you just want to spend your time assuming it is this sort of worst case scenario and not try and do any more work that way?
Yeah, I'm really hampered on this one. It's always the great sim case, Steve, the flight control team. What do you have? Because if it was nitrogen and you burned it off, you lost your system, and it was no impact. But we just don't have enough instrumentation back there to be able to definitively say it's hydrazine or it's nitrogen. I got a lot of circumstantial evidence that says it's nitrogen, and let me expand on that a little bit. There's a lot of temperature transducers back there, and if I had any free hydrazine escaping and freezing, if it was around one of those temperature transducers, I would see that. If it was on one of the heater lines, it would change the amount of current draw that heater would require. I'd be able to see that. I haven't seen anything like that. There have been no anomalies in the aft on any of the heater stuff with the exception of APU-3. And we all thought, oh, hey, look, APU-3 has this funny heater that's running at a higher set point. Why is it running at a higher set point? And if you look at the way that the aft is all plumbed together, there is almost no way that you could get hydrazine escaping from the fuel tank number 1 going across the aft to APU number 3, getting between the sidewall where there's a blanket and the fuel line that's wrapped up with a heater on it over. It's completely across the bay against the sidewall under a blanket, and we thought, yeah, that seems a little bit hard to swallow. We think it's just a coincidence, and we haven't seen any other kind of indication on it. So you would expect if you really had some kind of hydrazine floating around in there that was not vapor, that you might have seen it on some other heater, some other wire, something else back in there. We haven't seen any of that except the APU-3. And that, I didn't talk about that today, but the analysis stood from before is that we did some work back there. It was very difficult to bond these heaters around this line, and we think one of them just debonded, and that would give us the same signature that we're seeing. So I am a lot of people that I trust that know a whole lot about how the vehicle's put together, how the vehicle's serviced, have come up to me and said, John, it's an N2 leak. Don't worry about it. And I just can't do that. To me, it is still a coin flip. I think we need to treat it like a hydrazine leak, treat it appropriately and make sure that what we do assumes that case, even though it's worst case. And I'm not going to come off of that for the duration of the flight, because I just don't have enough information to conclusively say that.
Mark.
What's your confidence in the other two APUs through this analysis? And then I have a follow-up question.
Yeah, we have no reason to suspect anything with APUs 2 or 3. They performed extremely well through the ascent time.
Thanks. And could you just review, and can you do this from time before landing when you start to turn on the APUs for the descent?
Typically, we'll start one APU at 5 minutes before the deorbit burn. Just make sure you have one running good. The discussion right now is, hey, we would probably make that APU number 1 just to burn some additional hydrazine off of it, just in case it is. And then we do the deorbit burn, and 13 minutes before we start hitting the sensible atmosphere, it's entry interface minus 13 minutes, we start the other two APUs to provide sufficient hydraulic power while you're in the atmosphere. All three typically will run all the way down through landing. You'll land, and then you do post-landing where we reposition the main engine bells. We put them in what's called a rain drain position so rainwater cannot collect in them, and then we'll end up shutting them down. And then we're usually 10 minutes or so after landing, we end up shutting those APUs down. There's been some discussion if it's running and running fine, just leave it running until it underspeeds on the runway. The Kennedy Space Center guys said that's really not required. We're going to talk about it some more tomorrow. That'll be in the overall plan for how we're going to treat this APU.
Sorry, I thought of one more question. Is there, I know you're managing the landing strategy so that you use KSC as your prime landing site. Is this driving any sort of rethinking about turning or having California available to you at this point?
Yeah, no, not at this point. If we ended up burning the APU off, if we saw the pressure change when we burned it off, we would have to meet what's called single APU weather placards, which are more restrictive. And at that point, I would call up Edwards just to give us more opportunities to land. It would be a challenge this time of year to meet the single APU placards at Kennedy Space Center. Let me give we talked about flight rules a lot yesterday and today. We have a lot of rules on APU leaks. We have a lot of rules on what APU leaks mean to you. We went through them all, and it was good information, but the context of the discussion was that those rules were written assuming a very large leak. It was not for this little seep kind of leak that we have right here. And the rules don't really apply. You know, I saw that some folks were thinking the APU was lost, and it is not. The rule was not written to be, you would declare this APU lost for this case. And the folks that wrote the rules and are responsible for them, you know, they kind of came forward with that context, said, here's what the book says, but this is not really what the book was written for. This is not really the case that we intended. We intended it to be a very large leak where you're really dumping hydrazine into the aft, and this is what the kind of path you would go down. It doesn't really apply as much to this one. I also forgot something else. You know, folks have talked about STS-9. We have had another leak in the program. It was during the approach and landing tests, actually the first one, and we dumped gallons of hydrazine into the aft from a leak at the, it's called the fuel seal drain cavity. There's a cavity, there's a seal that keeps hydrazine out of some parts of the APU. Basically, it was going overboard, and it was coming right back in the vent into the aft, and we put a whole bunch of hydrazine into the aft, and it really didn't cause any damage or cause any problems because it didn't hit any hot spots back in there. And so it's a very specific, you have to have a very specific set of cases to get above a flammability limit and then have an ignition source to get yourself into a case. I will not minimize the fact that you don't want hydrazine in the aft. You just don't want that. You don't want hydrazine anywhere because it's not a nice substance. But we have had a couple leaks in the history of the program.
Todd Halverson of Florida Today. Just so I make sure I'm clear, when you turn on this APU in the flight control system checkout, what that will essentially give you is you'll be able to gauge the decay rate and see if it increases and therefore either gain more confidence or less confidence in this particular unit?
Yeah, I don't want to oversell how much it's going to tell me. Basically, I'm going to start it. I'm going to put it in a low vibration environment. I'm going to run it kind of like I would for entry. It's not very much different from the entry environment. And then when we shut it down, I'm going to sit there and watch the fuel tank decay and make sure it's the same, and that if we have a crack in a stem, if we have a poppet that's not seated, that it didn't get worse. There is not a great test that tells me everything I want to know about exactly is it GN2 or is it hydrogen. See, we're stuck here. This is just one of those cases where I don't have enough instrumentation to know, is it nitrogen, which is no issue at all, or is it this hydrogen leak? Well, the leak size is not an issue at all. But if it got worse, it would be an issue. So we're gonna go run it for FCS checkout and see what we get.
Okay. And on the other one you covered today, I'm wondering, just walk me through this, how you get from a pressure differential on the forward part of the the reaction control system. How is that an indicator that leads you to the possibility of a hard slapdown?
I didn't explain that well. I didn't bring a picture, but you know the forward RCS is just a module you can pluck right out of the front nose of the orbiter, and this is basically the wall, the structural wall behind that forward RCS module, and it does pick up loads whenever you come and slap down, because the nose wheel is pretty much right there. So if you put if you broke something on that bulkhead itself, then when you did your slap down, you could end up breaking it worse. You could end up damaging the bulkhead itself. And what the team has gone off and done is they've looked at that pressure differential that they saw, which again they think was instrumentation. They looked at that pressure and said, okay, if this was real, would I have damaged any of the structure, And the answer was no. Then they said, okay, well, if I did damage the structure at all, if I had my worst case slap down loads and those loads were transmitted up to that bulkhead, would I damage anything there? And the answer was no. I sent them back though because it was what they characterize as a quick and dirty analysis, and we're going to go back and make sure we do the right analysis and that the guys look at it very carefully. And but that's kind of where we are right now.
All right. Thank you. Tarek Malik with Space.com and Space News. John, when you say we're okay where we are now, does that pretty much mean that everything else aside, if nothing changes, you're confident that you're not going to have to do anything untoward or different prior to landing? And then if you do have to vent or burn off, I guess, that APU, does that basically push just your target landing back? Would you just go an extra orbit and come back for a second?
No, it really would not affect our landing opportunities at all. I think we would do it, like I was telling Irene, on the day that we did FCS checkout, which would be tomorrow. To answer your first question, we got to be really clear. Yes, if it stays where it is right now, I am very confident things are going to be just fine, and that we're going to use it just like we had planned pre-flight. And the FCS checkout is going to give us an opportunity to kind of look at its performance and make sure nothing else is going to happen. I really have to stress, it went through a pretty severe environment during ascent, as all the gear does. That environment is much worse than the entry environment. So what we're thinking is that if something loosened up, if you're getting some leakage at a joint or something else, it's not going to get worse during entry because it didn't during ascent. We have the guys running all the analysis to show that's true.
Guy. Yeah, Guy Gugliotta from the Washington Post. I have a couple of basic questions about this APU system. I don't understand. Is the tank pressurized enough so that there's enough pressure to drive all the hydrazine to the APU without making it up, or something like that? Is that the way it works?
It's a pressure-fed system, and you have the hydrazine that is pushing on the bladder, which is pushing the hydrazine down the feed line. There's a fuel pump in there that's drawing it and providing the appropriate amount of pressure to run the APU itself.
But you don't have to make up the N2.
No, no. As a matter of fact, the starting point for the pressure required to start an APU is about 100 psi. And that was the discussion on the GN2 side. If the GN2 got a lot worse, you're still a long way from losing the capability of running that system. We were up at around 200 and, I don't know what it was, but it was well above 230 psi. So we're 130 psi from the start requirement.
And so when the hydrazine goes down there, it drives a motor? Does it drive basically a gas generator?
Yeah, an APU is a little rocket engine, is what it is. You have hydrazine going into a catalyst bed that breaks it down, and that is turning a turbine, which goes into a gearbox, which is driving a hydraulic pump. And that hydraulic pump is pressurizing the hydraulic fluid to move the elevon, body flap, speed brake, rudder.
One last question is that this one is only for the landing gear. This doesn't do the elevons.
It does. It does all those things. It does.
Now, do the others do all those things as well?
Yes. There is what's called switching valves that one APU can drive everything but the hydraulic landing gear deploy, and AP1 can do that as well. If you have all three systems up and running, then they all are plumbed in to be able to control the elevons, body flap, speed brake, all that stuff.
So then if you have to cut something off because you don't have enough juice, then it's the
load is picked up by the other hydraulic system.
And then the landing gear is the first thing you would lose.
The landing gear is
the thing that you would have.
I confused you. It's my fault. I didn't explain it well. All of the aero surfaces, the elevons, the rudder, the speed brake, the body flap, are driven by however many systems are available. If you have three systems, they're driven by three systems. The way the plumbing works is it prefers one system. If that system fails, you got a valve that turns and it goes to the next system. Okay. The landing gear deploy, though, is only fed by hydraulic system number 1. And if it fails, then you go to a pyrotechnic deploy. We did not put the plumbing in to let system 2 or system 3 drive the landing gear.
One of you start with this?
Yeah. One of the New York Times. You mentioned if you go to a 2 APU situation, you activate Edwards. Does that mean you cannot land at Kennedy with 2 APUs, or just what is the decision point there?
Sure. The vehicle can be flown on 1 APU, just fine. But what you would like to do is have the best weather possible if you went down to 1 APU. If I have 2 APUs, I have full control. I don't limit the rates that I can use on my aero surfaces. I don't change anything really. So what you do is if you're down to 2 APUs and you know that, you go make your weather constraints a little bit tighter so that you're not into a crosswind situation. You're not into anything that would cause a lot of movement from a piloting standpoint. And that's only to protect if you lose another APU and get down to a single APU. So if I have 2 APUs, I tighten up my weather. This time of year, landing at Kennedy Space Center, the weather's a little bit flaky. I would think that I would have a much better chance of landing at Edwards. I would call them both up, and I would pick whichever side had the best weather to go land at. But it's fully capable to land at either side.
Another follow-up on that. If you have 2 and one of them is APU 1, is that different than having 2 and having APU 2 and 3?
No.
I mean,
no. The only difference is that the APU 1 would be able to control the landing gear.
Okay. And have we ever used the pyros to land, to knock down the landing gear for a landing?
No.
Okay, so that would be different or new if you decided to go somewhere else.
That's true.
Okay, let's wrap it up. It's getting late for everybody, and we'll do it with the usual television schedule programming notes. The crew is scheduled to wake up a little after midnight Saturday to get ready for the farewell ceremony with the International Space Station crew and also the undocking. Undocking is scheduled for a little after 5 tomorrow morning. We'll have a mission status briefing with the off-going flight director about 10, and then John will be back tomorrow after the mission management team, currently scheduled for 4 p.m. Central Time. And that FCS checkout that John mentioned is Sunday morning, scheduled to begin a little bit before 3 a.m. So with that, we'll throw it back to Mission Control and head back to space. Thanks.